Celebrating 18 successful years of BT cotton cultivation in India. Good morning, everyone. Good morning. Welcome to yet another powerful, power-packed webinar on Biotechnica's platform. And today, we meet on a special occasion, an occasion where we celebrate the success of BT cotton. 18 years ago, when most of us were children, our policy makers took a significant decision that changed the face of cotton farming in India. But the journey of BT cotton has been full of controversy. In fact, for every technology in this world, we will always find some critics, some naysayers, ready to criticize. Am I right? Yes. Now, whatever might be their intention or motive, I wish to make a very strong point today, right here in this webinar. You see, controversy is the brainchild of illogical and unscientific people. As scientists, we always believe in proof, evidence, and logic. And when we don't have it, we look for it. And that is the reason we are scientists. But one thing which our scientific community needed was a platform where they could come together and express their logic, their evidence, their proofs. And today, we intend to address just that. Today at Biotechnica, we don't want to just celebrate the success of BT cotton, but also want you all to unite, to come together on this single platform so that no other future GM crops faces the same hurdle which BT cotton faced. And that cannot happen unless, of course, you share this webinar link with all your friends and peers in the scientific community, share it on Facebook, LinkedIn. Let us bring the entire scientific community of India and the world together on this platform, right? Now, this webinar is not just by the scientists. It is also by the farmers who are going to share with you their live experience of cultivating BT cotton in various states of India. Farmers are solely responsible to bring food to our table. And if farmers of India are suffering, then I don't think any progress is meaningful progress. Am I right? Yes? Exactly. All right. So now it's the time to get started with the webinar. But before that, I wish to inform you all that we'll be giving away participation certificate and two special ebooks written by Dr. T.M. Manjunath to all of you if you attend till the end. So promise me you are going to be there till the end. Yes? Okay. All right. All right. So with this, I also wish to welcome Professor Dr. G. Padmanabhan, former director of IISc, senior advisor at DBT BIRAC, members of the Department of Biotechnology, Government of India, and members of ABLE, Association of Biotech-Led Enterprises, who have been mission critical in this webinar. Apart from that, we also wish to welcome the honorable vice chancellors of various agricultural universities who are attending this webinar today. Also, officials from seed companies, journalists, technocrats, students, scientists, Biotechnica members, subscribers, and most importantly, the farmers. We welcome all of you to this webinar. And now we will be starting the session. I'll be passing on the controls to our coordinator, Dr. Jagadish Mittur. Thank you so much.
Thank you so much, Shekhar. A very good morning to all of you. Thank you, Team Biotechnica, especially its team lead, Mr. Shekhar Suman. I absolutely adore this Biotechnica platform. It has such brilliant policies and agenda to reach out to thousands and thousands of students, faculty, and others pursuing their professional careers in biological and chemical sciences. And that happens through Biotechnica for biology students and Rasainika for chemistry students. This is highly essential as both biological and chemical sciences have huge impact on agriculture, on pharma and health, on energy, and the very key to our existence, our environment. Friends, a wise person said, any science being pursued, if it is not relevant to societal needs, then it is just honorary science. Let me repeat that. Any science being pursued, if it is not relevant to societal needs, then it is just honorary science. We do not have that kind of luxury of doing honorary science, at least in India. Science and technology must always respond to societal needs and global challenges. And as you know now, the reddest and the very hottest topic now is COVID-19 disease. We are struggling to get a vaccine that should have been there, not just yesterday, maybe months ago. And that's where the science and technology is being focused on. Students, while pursuing science, generally study for passing exams. They do not really have in their mind the aim of finding answers to challenges and contributing to societal needs. I used to be like that, but I hope you all students are not like me, but more oriented towards societal goals and finding solutions to the challenges. In today's webinar, students and others will have a great opportunity to see how the careers can be a challenge-driven, how your contribution can make an impact to bring in societal benefits. Today, it is about biochemical and plant genetic sciences and their impact on agriculture. Today, we have thousands of students, many scientists, and most importantly, our farmers in this webinar. We also have highly recognized pioneers in the areas of biotechnology, like Shekhar mentioned, Professor Padmanabhan, who is a Padma Shri and a Padma Bhushan, members of DBT, Vision Group of Biotechnology, Government of Karnataka. And also, I hope there are skeptics who are not quite sure of the technology, or the opponents who have been opposing this technology over many, many years. I hope they are participating too. We welcome all of them. Friends, just a very small note on farmers, building on what Shekhar said about farmers. Let us please remember that it is farmers who feed us at least 3 times a day, clothe us for protection, and offer care for our cattle and sheep. It is because of the farmers who continuously worked, even during lockdown period, that we are food sufficient as we speak from our respective homes or our official offices. Please kindly cheer for farmers with your comments. What comes to your mind? Joyful comments, I hope, on the chat box of Biotechnica platform. Friends, you know, many a times we hear from a few, thank God it's only a few, that scientists invent technologies just for fun and then go around looking for their application. I don't think that's the case. I don't know who they are. In all my view and experience of over 4 decades that I have been in touch in various countries and cities, conscientious scientists are always challenge-driven, society-driven, and they know that it is very cool to do science because it's going to bring in societal benefits. Today in the webinar, we have an opportunity to showcase a few scientists who had identified a particular challenge decades ago in agriculture, a specific disease, so to speak, which attacked on crops. And that particular disease is the bollworm disease attacked on cotton. They found answers and developed solutions in such a way that is meeting societal needs via the most important stakeholders of all, our farmers. Because of these types of efforts in the past, we have food, feed, fodder, fiber, flowers, fruits, and so on in sufficient quantities, at least for now. What's going to happen in 2030? What's going to happen in 2050? We're not quite sure. It remains to be seen. But somehow we must be prepared to face the consequences. We must remember, just because there is one cure for one pest or one disease, it does not mean that there are no other diseases for the same crop or for the same plant. It will always be a constant battle between crops and diseases, as is the case in humans and animals also. A cure for one disease does not mean there is a cure for all diseases, be they be viruses, bacteria, or fungi, and oh my God, locusts, the recent storm of locusts. So dear listeners and viewers, today in the webinar, we have an opportunity to demonstrate how scientific inventions in laboratories have reached farmers, sustaining over 18 years. You will hear 3 scientists, actually 4 scientists, and 6 to 8 farmers speak their experiences. They provide clarifications and answers to many questions raised by the skeptics and staunch opponents. We have 8 farmers speaking from their own respective crop fields, actual farmer fields, green fields. And to me, this is exciting. I hope it's exciting for you also. So that's the format of the webinar. Please stand by. With this brief introduction, let us get going. I want to give an opportunity and a platform to Professor Padmanabhan just for about 3 to 4 minutes to seek his wishes, because he's one person who has been right there from the very beginning. He heard about this technology. He works on malaria, he works on vaccines, but he knows about agriculture to the extent that he can identify if there is a new technology, how it can make an impact on the society, particularly on the farmers. I think you all know him, as Shekhar introduced him. So I would now like to pass on to Dr. Padmanabhan to hear his few words. I'll come back after that. Thank you so much for giving me a chance to give this introduction. Thank you.
I want to thank Dr. Jagdish Mittur for inviting me to this program and asking me to speak a few words. There are going to be real experts and practitioners of BT technology today to address here. My field is not really agriculture, but I have tried to follow technology development since I have felt agriculture is the lifeline for this country. I observed a curious thing. Whenever there is an occasion to celebrate, I am told it is 18 years of successful introduction of BT cotton in India. There will be a spate of articles put the technology down. Unfortunately, some newspapers are also biased. One may be able to write a well reasoned out article to contest the one in the Hindu, but is unlikely to get it published. The fact remains that there are so many variable factors, including fertilizer, pesticide, rainfall, weather change, and BT is only meant to protect against a lepidopteran insect, which it is still effective. But BT has no growth promoting properties. But I have read that nitrogen uptake is more in BT than non BT. Obviously, there are some beneficial effects of the gene in addition to pest protection. India became a cotton exporter only after introducing BT cotton. Is it because farmers took to it and the acreage increased enormously? Why did this not happen with non BT? Of course, the easiest thing is to blame the MNC, but I think farmers are smarter than scientists. I find that there is no control data to argue against BT. Do we have comparable data on non BT in India cultivated over 11 million hectares under various climatic and pest infection conditions? Had we not introduced BT cotton, would India have become the world's largest production of cotton, whatever be the reason? I also think that India is the only country using BT cotton hybrids. Other BT growing countries use varieties. I understand that the lower yield in varieties is compensated using dense packing, which is not possible in bushy hybrids. Of course, BT hybrids were a revolution when introduced, but the institution devoted to cotton failed to develop BT cotton varieties in time. Now there is a clamor for varieties. We all know the history, and I guess BT cotton varieties will come up eventually. Ultimately, gene editing will replace GM in the sense of bringing a gene from outside. My concern is India is not only decided or undecided on GM, but also on gene editing. Countries are making great progress in agriculture using gene editing. Activism against gene editing in agriculture is a worry. In the name of organic, anything can sell. These are all crucial areas to make progress in agriculture, in addition to application of artificial intelligence, soil health, water use, and policy initiatives. Why modern technologies do not get serious attention in India in terms of policy, despite a huge support from the Department of Biotechnology. I'll stop here.
Thank you, Professor Padmanabhan, for sharing those encouraging words and also identifying gaps when it comes to implementation of policies and so on. With that, I would now like to open the session on the three scientists. And initially, I would like to invite Professor C.D. Mai, one of the many Mr. Cottons of India. So Professor Mai is currently the president of South Asia Biotech Center. He's currently based in Nagpur. He's got PhD in plant pathology from IIRI in New Delhi. He's contributed extensively to crop diseases, epidemiology, management of oil seeds, millets, and vegetables. He has conducted mega demos on 500 acres on high input drip irrigation, fertigation technology, specifically in cotton. He has led the most successful ASHTA project on low input technology in cotton. He's associated with the release of BT cotton as a key member of evaluation and also a member of the GEAC EPICS body. He has served as a member on ISAAA, Biosafety Network, International Service for the Acquisition of Agribiotech Applications. He's published many papers, chapters, and so on. He's a member of several committees of Government of India. So if there is someone who is aware of what's happening with cotton, its history in India, as well as how it's evolved to the current state, it's got to be Dr. Mai. I would like to welcome Dr. Mai to take about 13 to 14 minutes or 15 minutes to please share his views on the evolution of cotton and how we have arrived at BT Cotton. Thank you so much.
First of all, let me thank Biotechnica for a wonderful opportunity on to speak on the evolution of cotton cultivation in India, particularly for this webinar, which we are organizing 18th year of BT cotton cultivation in this country. Friends, let me tell you that cotton is not new to India. Desi cotton, or what we normally call as Gossypium arboreum, is actually originated in India millions of years ago. And probably we all know that Dhaka muslins, very, very famous, or what they call it as calicos, are basically Indian types, and therefore is very famous. Like Egypt and South Europe is famous for flax, West Asia and North Europe is for wool, China is for silk. So India was very famous all over the world in the olden days for cotton. And probably you all know that the British India Company, which was established in 1631 India, actually with the royal charter presented to the Mughal emperor, set up factories in Surat and in Madras, then called Madras, Chennai, in 1639. Actually, cotton trade actually to Britain began in almost 1640, and it was already started from Calicut. That's why probably you know the word calico has emerged from that. And India was therefore that time the largest exporter of cotton textile. So cotton is not new to India, and it's slowly entered. I will just now come to what has actually happened. Post 1947, we have series of changes which have occurred in cotton. Like Deshi cotton was slowly replaced by what we call it as American cotton. That is Gossypium hirsutum. We call it a technical word. Quality improvement was also given impetus with yield in the new cottons. And the Egyptian cotton was also tried. Now Egyptian cotton is another third species called as Gossypium barbadans. So we have Gossypium arboreum, Gossypium herbaceum. These are Deshi cotton, which were already grown in this country. But these two other species like American cotton, hirsutum, and then Egyptian cotton barbadans, they were also brought in India because for quality issues, research was concentrated then only on hirsutum, because the barbadans was actually more susceptible to pest under our conditions, and there were a lot of insecticides need to be used for control. So this was all during after post independence. If I will just call you briefly, what are the landmarks that India has? You will see that we introduced these improved arboreums like Jaidhar, MSU, Fayu, which were 60s counts around 1950 to 58. But the first world cotton hybrid, H4, was released, and it was done by a very renowned scientist called C.T. Patel from Surat. And this was released in 1970, which changed the entire concept of cotton cultivation. And that's why I think nowhere in the world hybrids are grown, but it's only in India. Actually, we also introduced Suvin, high count, 120 counts released in 74, but it was all restricted only to South. And the other major intervention which has occurred is that I call it as synthetic pyrethroids were introduced, because bollworm became a big problem with American cotton. And that's why in 83, synthetic pyrethroids were introduced. And subsequently, this resistance was also developed, as I think earlier also speaker has very rightly said, that resistance was developed to it. And therefore, this problem of bollworm became so acute that we had no alternative than to introduce something new technology, and which was already prevailing in US, like BT cotton, which I think was introduced in 2002. And you can see that after 2002, and then immediately in 2006, the single BT cotton, that is Bollgard 1 and Bollgard 2, they were introduced, and the entire concept changed. And I would like to show that cotton is the only crop where we had a lot of technological inputs given after independence. For example, arboreum to hirsutum. So we have made a change, and our million bales have increased from earlier to 6.80 million bales. Earlier, the productivity used to be only something like 80 kg lint per hectare, but then it improved to 120 to 140. Then hirsutum quality improvement was made. Then hybrid adoption, which I said already, was introduced, and it made a substantial change in the production scenario. Nearly 9.90 billion bales were added to our productivity. And then the major issue came with what we call it as technology fatigue came between 1992 to 2002. And that's why we introduced BT cotton, where 32 million bales were in. So every technological change in cotton, and this is the only crop in India which received all kinds of changes in the technology and adopted by farmers. This is how I have just put up a graph that what are the phases of what we call it as yield stagnation. It's a very characteristic of India. If there was a yield stagnation because we had used arboreums, when we introduced hirsutum, after some time it became again something like stagnation yield till we introduced hybrids. Hybrids have improved, or pyrethroids could improve, but again there is a stagnation. And then now we introduced something like 2002 BT cotton. BT cotton has straight increased, but again there is a fear now that our productivity shall be around 500 again. How long? And what are the next technological inputs needed to really improve upon? I will just talk about, because it's a webinar. Basically, we are devoted to 18 years of BT cotton. How did India break the barrier of last century yield stagnation? And that was what I said, that something like 300 kg lint per hectare was between 1985 to 2002. Very long period. And farmers used to worry. Every alternate year there was an epidemic or epizootic of bollworm. And bollworms is all constituted because American bollworm, then we have pink bollworm, we have other. So all those four bollworms, but the major was American bollworm. And the yield was stagnant for 15 years. So barrier of stagnation removed by adopting what we call it as BT cotton technology in 2002. And probably this is the first, and now itself after 18 years, the only biotech product available officially in India. And it has changed the entire scenario. Why? Because the farmers were tired of spraying. 14,000 metric tons of insecticide were bollworm per year were used. 50% of the total pesticide were used on cotton, which was grown only on 5% of area. And yield losses used to be something like 10,000 rupees annually. I think this is what I said, that changed. Insecticide for bollworm alone used to be sometimes in the even dry land 15 to 20 sprays. In wetland in Punjab, it used to cross even 20. And that is where I think it became totally uneconomical. How BT cotton has changed. You can see the major target therefore that time was to control bollworm without much of insecticide. And that is how it has been achieved by actually, if you see, insecticide usage was already at the peak, something like 1992-94, where we introduced then IPM, then we introduced IRM, and then we introduced BT cotton. So that all the three, they have simultaneously gradually reduced the consumption, and the bollworm insecticide reduced from 6 billion to rupees 2.6 billion by 2008. So it's a very significant kind of a thing. Now, adoption of BT cotton simultaneously has a side effect, because once you control bollworm, the yield increased, and therefore the more adoption, because farmers don't understand. They understand yield perfectly. So the adoption of BT cotton is very fast. You can see how the area has increased, how the dotted line area, how the BT cotton actually the production has increased, and how the yield has dramatically increased. So this is something which possibly has been given. And if you compare now what is the adoption of BT cotton farmers in India and USA between 96, you can imagine that initially it used to be slow, but by 2008-9, I think we crossed the number of farmers adoption even more than what US have. Today, BT cotton is almost grown on 96% of the total area. I think this is the success. I would always call that those who say that BT cotton has failed, why don't they ask the farmers that why are they growing? I will show you some other slide. The other impact is, I will not show all the impact. It has an impact on the total composition of your quality cotton. It has also, changed the composition of the quality. Then it has also changed the export potential. As it is from import, we used to import something like 25 lakh or 2.5 million bales. Now we have touched 9 million bales of export once in the last few years. Again, there is a decline, but these are all depending on what is our own utilization in the country. And I think that is more better. Now you can see, this is a very interesting slide because this is after 2000, something like 13, 14, when we reached peak of yield. Now there has been slowly again either a decline, a slight decline, or it is stagnant. So this phase, this is a very characteristic of Indian cultivation. It goes for some time and then it gets stagnated. And then we need what we call it as a technological boost, like BT cotton. What kind of technological boost will be needed? Now we imagine that what are the immediate concerns for farmers? One is that they need something like what we call it as mechanical picking, because labor is a cost. And that's why people are illegally growing what we call it as HTBT cotton. Maharashtra alone this year, 15% of the area is under illegal HTBT. I will be not showing those slides, but it is very interesting that farmers are going because mainly there is a big problem of labor in the picking and other issues. And the cost of picking is so high that probably they become very uneconomical. Now we have also tried with my colleagues in CICR, they tried the high density planting. And high density planting, what we need is what we call it as early sowing. The crop escapes really bollworm situation if we can do that early sowing. And then we have to also use, because there is a close planting and chances that humidity is very high, bollworm control may not be difficult. So we have to use insecticide, less insecticide. There are some what we call it as factors which will really be useful. For example, you can see semi-compact varieties are needed for HDFC, and which is planted at 45 to 100 centimeter spacing between rows and 10 to 50 sowing between plants. Now, these are the HDPS or high density planting system which were tried with semi-contact varieties without any BT. But then these are several trials were carried out. I must say that CICR has done quite a good amount of job earlier from between 2012 and 18, nearly 6,894 demonstrations in all over the cotton growing states were tried. There are mixed results. I would say that it is, the results are sometimes you can say 50%, very good results. But because in many places there has been a lot of attack of bollworms and pests because of close planting, the varieties could not stand and the acceptability of the farmer has not been there. Now, for example, then there was a lot of many companies, they tried to shift that why high density planting with varieties, why not with hybrid? Because they tried also to have compact hybrid variety. Confederation of Indian Textile Industries along with Rajasthan government tried this HDPS with BT hybrid. Hybrid surpass, this another 7007 hybrid was tried by 18 to 15. But this could not be to that level of a variety because naturally hybrid has its own limitation. And the population can vary from between something like 25 to 30,000. While in varieties then can go for 80,000. But then you will have to also see that the management of pest has to be done in a variety not in hybrid. With BT hybrid, there will be. So I think this is one change, that high density planting it is to be done, then naturally one can go in with hybrid. And I have already shown that there are results which are carried out in Maharashtra, where the yield has increased with HDPS using the normal practice and with HDPS, and the gross income has also increased. So I think there are chances that HDPS with BT hybrids would be another wonderful proposition. But there are tips to be given. Select appropriate genotype, early crop establishment, maintenance of land population, and soil water conservation. Some of those issues, they must be tried very well. I think last few slides I would like to show. After 18 years and after a consistent negative campaign, why farmers are still growing BT cotton. This, my association, South Asia Biotechnology Center, carried out 2 surveys. One was carried out in 2013 and one was carried out in 2019, very recently. I think these results kindly make a correction. I will be doing that in the final year. This 2013 should be actually 2013, 2019 is right. Say, for example, increase in yield was the major reason in 2013. 2013, bollworm control was the major, because this 2019 should be replaced by 2013. It is reversed. So you can see that time bollworm control was the major problem in 2013. But now they are growing BT cotton mainly because of yield. So sucking pest control is not important. Ease in cultivation, even that time there used to be only 59%. Now they say that ease in cultivation is not much, because there has been some problem of pink bollworm for the last 2-3 years. Now pink bollworm, we have done a wonderful campaign and suggested farmers. So last 2-3 years there has not been much of pink bollworm also. Once you educate, make them aware. So I think the best way is that the BT cotton is going to stay, but now we have to see that what agronomic practices to be changed so that the other pest can be reduced and our yield can be improved. HDPS can be tried. Mechanical harvesting also is needed, and that's how I think the entire situation will have. So let me tell you, friends, the king cotton, India cotton is the king. It will come back, and it is already there. And I'm sure that with new technologies, it will definitely come. Cotton is cool. Everybody wants cotton, and India is the home for cotton. Therefore, we should concentrate that we should allow our farmers to grow cotton in the best possible way, and still in the dryland situation like Vidarbha, where I am sitting today in Nagpur. Friends, farmers are growing cotton, and that is the only crop which is still surviving after heavy rain. This survives with low rainfall, and that's why they do not want to leave cotton. Only thing is, we should give them technology boost every time to achieve. Thank you very much.
Thank you. Thank you so much, Professor Mai, for going into the history of cotton in India, its evolution, and to BT cotton in India, and on all the details. And leaving all of us on a very positive note, encouraging note that India can get that coveted spot of being king cotton, and of course, cotton is cool. So thank you so much. We'll get back to you during the Q&A session. Friends, I really now would like to connect you to the 2 farmers. These are the first 2 of the 8 farmers that we'll have today. And the first one is Mr. Balbinder Kong from Rajasthan, a very lovely area of India. And he's been in the area of growing cotton and other crops, and he's going to be coming to us live. Please kindly take it to Mr. Balbinder Kong in Rajasthan. Following him will be Mr. Gurjeet Singh Man of Haryana. So from 2 different states in the northwestern part of India. Thank you very so much.
Good morning, friends. I'm Balwinder Singh Kang, a farmer from Rajasthan, India. I'm a cotton farmer and I've been farming since 1984. Uh, Before we got BT cotton seed, say around 2003, most of the trials for BT cotton were conducted on my fields. And I saw the basic advantage what this variety has, this technology has. Before BT cotton, we were on the verge of selling our land almost. Every year we were losing money due to bollworms. The yield was going down every year, and we had no options, no technology, nothing was available. Then, when I saw this technology, I saw the benefits. Before that, we were spraying almost 30 times in a crop cycle for bollworms, and whenever we were moving around towns and highways, all we were inhaling were fumes of pesticide. Every farmer was in the field spraying one or the other pesticide. And suddenly this technology comes and we see the benefits. I was the first farmer in my area to start sowing BT cotton. And gradually now almost 99.9% farmers who sow cotton in our area are BT cotton farmers. Now we just have to spray 3 or 4 times, and that is also for sucking pests. Most of the anti-GM technology people say, okay, you have to spray. Yes, it is only a technology for, I'll say, bollworms. And we need such more technologies like drought tolerance, and if we can get something for sucking pest, then HTBT cotton. It's the need of the day. Banning glyphosate is no alternative. Basic is we don't get labor now. We're paying 300, 400 rupees per day to a labor, and he's still not willing to come. And it's so cost incentive. We have nothing, no way to reduce our expenses. Picking is going up. It's almost about now 10 rupees a kg. So almost 15 to 20% of whatever we get from the market goes into cotton picking. And some people say, no, there are alternatives to this GM technology, high density. We've tried high density from 20,000 to 60,000 plants per hectare, but it's not working out. There is more pest attack. The sunlight does not penetrate through the plants, and there's more fungal and viral disease on the plants. So it doesn't work. So it is this technology only that because of which we were able to survive, save our lands, get my children good education. And then again they say, okay, we need short duration varieties, another alternative, which I don't think is possible. Short duration is 120 days. We complete our sowing round 10th of May. Start mid-April and finish by say 10th of May. But in 120 days, it comes to September when the crop is almost ripe. How is it possible? If we delay the sowing, then the temperature rises above 45 in mid-May, and we are not able to get a good germination. So we can't delay the sowing. And July and August is the peak season for monsoons in our area. So when there are heavy rains, there's a lot of flower and ball shedding, spray shedding. So how can you get a good crop? This is almost August end, and I'm sweating and standing in my field. So how can you get labor to pick cotton in these days? No one's willing. I can't stand it. There's no so high temperature, so high humidity. So that is not an alternative. We need crops at least 140 to 160 days. Then the quality is also better due to the weather season. Rains go on till say mid-September. So if the opening is there September beginning and there's rain on it, the quality of the cotton will deteriorate very much, and you don't get a good price. You are not able to sell your produce. So I think the best solution to the problem is people who are not willing to let this technology come. Why don't they come down to my farm, stay for a crop cycle? I'll use their technology and my technology, and let's finish it for once and all. See which one is better. If they are able to convince me, well, I'll go with them. And if I'm able to convince them, they should join us. These people are not practical. They haven't seen a farm, how a farmer works, how hard it is, what we go throughout the season. Basically, we are just gamblers. Every year we take a gamble and we hope at least some odds should be in our favor. Then we might be able to survive. And to get good incomes, like our Honorable Prime Minister says, double farmers' income by 2022. The solution lies in new technologies, mechanization, modern implements, and all these things at an affordable cost. I don't want a loan waiver. I'll much prefer new technology, new seeds. People have moved to the 7th generation, and we are still on the second generation of BT cotton. I sow brinjal also, and I'm spraying almost every third or fourth day for shoot borers and fruit borers, and still I lose about 50% of my crop. Why can't I get BT brinjal? Why can't I get mustard, GM mustard? Why can't I get maize? When we have seen the benefits of this technology, I'm guilty to the nation. I'm not selling vegetables, I'm selling poison. And it hurts my conscience. I don't want to do it, but I have to make a living as a farmer. So the government should look into it, get trials done. If there are no trials, how will we come to a decision? All trials have stopped. Nothing is working out. People are moving to the jet age and we are still on bullock carts. How can we compete with other countries' farmers? So the best solution is no loan waivers, nothing of that sort. Just give us new technology. We don't need anything else. We'll get better yields. We'll be able to survive. Even if the prices are low, then also because of a better yield, we'll get much more money on that. Thank you.
I am Gurjeet Singh Maan, a farmer from Sirsa in Haryana. Our is a family of 4 members, myself, my wife and my 2 daughters. Our family is into farming since several generations, but since 1947, our farm is located in village Patti Kirpal out of Sirsa. My grandfather, my father farmed on the same farm where I do it now. Before the advent of BT cotton, we had hybrid cottons. Prior to hybrids, we grew American cotton, also known as Narma, apart from the domestic Desi cotton. I heard about BT cotton being illegally grown in Gujarat. I and my farmer friends had a natural curiosity about why it is not allowed and why farmers are eager to get and grow it. Over some time, some of these BT cotton seeds reached even nearby Punjab area, and news about its potential of resisting damage due to bollworms spread by word of mouth. Positive and negative news about BT cotton started pouring in regularly, but farmers filtered it in their own earthy manner, and we were eager to at least try it out when possible. I resisted the lure of sowing any illegal seed, but did go to see the said BT crop at a location close by. In those days, farmers hardly took the story of legal or illegal seed seriously. For them, a seed is a seed always. Yes, it can be a good seed or not good seed at the most. The stories following the success of these F2 seeds were encouraging, as this was the time when everything failed to contain the havoc of bollworms. All chemical, mechanical controls, IPM practices, quiet practices, even prayers, nothing worked. The BT seeds were a ray of hope, In this, many were duped as the BT seeds they bought was not even a normal hybrid. But that does happen. I started growing BT cotton in the year 2003 when it was first available legally on only about 2 acres. And that was the first BT crop on my farm and in my village. Thereafter, there was no looking back. The area grew by leaps and bounds, not just on my farm, but on all regions where cotton is grown. This is a telltale example of nothing succeeds like success. The success of BT cotton improved our family income, reduced stress level of recurring crop failure. The success continued and was further augmented with the arrival of BG2. The signs of prosperity could be felt all over in the area. I cannot exactly recall when everybody had almost completely switched over to BT cotton in our area. I must acknowledge that state and central institute, especially CICR, which has an excellent regional center in Sirsa, conducted several farmer workshops and seminars for the awareness of benefits of BT cotton. Prices are driven by the market, but the concern of farmer was the yield and cost cutting. BT cotton helped in both. Over the time, while BT cotton kept its strong guard over bollworms, climatic changes brought in newer challenges to cotton. It was in the form of viral diseases, frequent attacks of sucking pests, thrips, etc., etc. Whiteflies, yes, whiteflies were terror. The reduced load of pesticides started rising again to control these problems. Slowly, it became harder to manage, and these new threats were as unpredictable as they were in the bollworm attack prior to BT cotton era. Same story of IPM, do this, don't do this, etc., making rounds. I was aware of HT cotton being in trials and in the regulatory pipeline. In fact, in my district, there were official trials going on both in public and private sector. The researchers were very introvert and tight-lipped, but I could cull the information that the present sucking pests problem has an indirect solution with this third generation herbicide tolerant BT cotton. Because the host to the sucking pests are weeds before cotton becomes their second home. Manual weeding is expensive, labor intensive, and time consuming. The HT cotton can give an easy route to weed management. I also could hear and know from science journals about upcoming potentials of GM crops, not just in cotton, but in variety of other crops as well. We were and are waiting for BT brinjal, BT mustard, BT corn, and BT soya crops. The unnecessary delay and continuing threats made me a bit averse to cotton, and also I had a more viable crop, basmati rice, which suited my farm soil type. I phased out BT cotton for basmati rice, but love for cotton farming kept my interest always in the cotton seed technology. In a recently held webinar by Pro Agri Science, for me as a participant audience, it raised many hopes and reasons. That right kind of next generation BT seeds hold big promise. Rice crop is only a stopgap arrangement as there is enormous pressure to discontinue water-hungry crops. Just in case any ban is enforced, then we need good BT cotton seeds, better than what we have now. Since these are already sown elsewhere, so I do feel that government will let us get these anytime soon. Take it to the farm, give us the options of better seed technology. We will pick up the best.
Thank you. Thank you so much, our two farmers, Mr. Balbinder Singh Khan from Rajasthan and Mr. Gurjeet Singh Maan from Haryana. Thank you so much for sharing your experiences and with cotton And also, thank you for your request to access other technologies. Now, I'd like to move on to the next scientist in the team of scientists that we have to share his views and his experiences in terms of getting BT cotton going in India. It's my pleasure to introduce Dr. T.M. Manjunath, whom I've known for many decades. He's an entomologist. He's a PhD in agriculture entomology from the University of Agriculture Sciences, and one of the most versatile agriculture entomologists with over 5 decades of research and executive experience. He has made pioneering contributions in the areas of biological control, integrated pest management, and insect-resistant genetically modified crops, with special reference to BT cotton. He was a key member of Monsanto Mexico team responsible for successful introduction and stewardship of BT cotton, the first and until now the only GM crop approved in India since 2002, and actually has made quite a big inroads, as you've heard till now. He is an author of over 130 scientific publications and 6 books to address at a very, very highly scientific level. Also, he's a very popular writer in regional languages as well as in English to reach out to the public who may be new to this kind of science and this kind of technology. With that introduction, short introduction, I would like to introduce Dr. T.M. Manjunath. Please kindly share your views on BT cotton. Thank you.
Thank you very much, Dr. Jagdish, for that introduction. Dear participants, I consider this as a great opportunity to share certain scientific aspects related to BT cotton, which include science, safety, benefits, certain myths and realities, and success. I will start with BT cotton, with BT itself. BT is the short name for Bacillus thuringiensis, which is a beneficial bacterium found in the soil. It has been discovered that certain genes present in Bacillus thuringiensis are capable of producing specific proteins that can kill cotton bollworms. Such genes in which we are interested have been isolated, studied, suitably modified, and incorporated into the cotton plant. This technology is what is known as genetic engineering. Such newly introduced genes, they become completely integrated into the genome of cotton plant. They are present in every cell of the plant and are transferred from one generation to another generation through seeds. Thus, it becomes an inheritable character. Genetic engineering is a remarkable breakthrough in modern sciences. In fact, BT cotton came at the most opportune time when bollworms were causing a lot of destruction to the cotton crop, and they had developed resistance and farmers were helpless. And in India, March 2002 is a very significant year because during that year, Government of India approved BT cotton for commercial cultivation in India. So this was the first GM crop that was approved. Before the crop was approved, it has undergone more than 500 field trials and a number of biosafety tests to satisfy that it is harmless to the non-target organisms. In fact, GM BT cotton is the first, and until now, even after 18 years, is the only GM crop approved in India. When this crop was introduced in 2002, about 29,000 hectares were sown with cotton. It increased every year, and as of last year, that is in 2019, about 12.6 million hectares of BT cotton were cultivated, which comprised about 93% of the total cotton acreage in the country. So this was cultivated by 6 million farmers, which is not a small number. BT cotton, because of its easy to use technology, and also it was able to control the bollworms very effectively, gave several benefits to the farmers. Because of the effective control of bollworms, yield increased from 31 to 67%, and it fetched a net profit to the farmers ranging from 7,800 to 30,000. there was a reduction in insecticide use from 25 to 55%. And as a result of all these things, about 6 to 7 million farmers were benefited by this technology. Their socio-economic status has improved. More than anything else, India turned from an importer to an exporter of cotton. Thus, BT cotton has revolutionized cotton cultivation in India, ably supported by other technologies, including crop breeding, agronomy, etc. But although BT cotton has achieved success, the road to success was not easy at all, because there was opposition to BT cotton from certain groups right from the beginning. They made allegations that BT plants are poisonous and harmful to human health and animals. In fact, they specifically quoted cattle, goats, and other animals. And other organisms, they said honeybees and earthworms are destroyed. And then also to the environment. They scared the public that BT gene will escape and contaminate the environment, render their other crops sterile, and destroy the biodiversity. With all these allegations, they went to the extreme of destroying the BT crops. And they also actually conducted demonstrations, street demonstrations against the GM crops. And also they protested against the other BT crops like BT brinjal. You can see the fancy dress here. So all these actually they have resorted to in order to prevent the crop from being grown. And their attempt was that BT cotton has been projected as a general poison that would kill almost everything. It has created a scare. What was not realized was the host specificity and safety of BT cotton. And the reality is that Bacillus thuringiensis is a soil bacterium. It is a beneficial soil bacterium which is distributed throughout the world. There are about 80 species of 80 subspecies of Bacillus thuringiensis which produce BT proteins. The unique feature of these cryprotein is that each cryprotein affects insects belonging to a particular order or particular group. For example, there are proteins which affect only Lepidoptera, which includes moths and butterflies, including bollworms. And there are those which affect beetles, bugs, and also the flies. And most important thing is that these larvae are killed in the very early stage itself. And what is important is that the utility of Bacillus thuringiensis was realized way back in 1938 itself, and it was used as a foliar spray. And before it was commercialized in India, BT cotton and other BT crops were commercialized in the USA in 1996. And since then, it has been cultivated on millions of hectares everywhere. But there has been no impact, negative impact, for nearly 120 years of its existence. This is because BT is very selective in its action. Although BT is present outside, it has no contact effect. It has to be ingested by the host. When once it is ingested, it has to be solubilized, for which it requires an alkaline gut. Then it has to be activated, for which it requires a pH of more than 9.5. Then it needs specific receptors for binding. So when it binds, it actually damages the tissues, and then the insect stops feeding, and finally it dies. So unless these specific conditions are met, BT will not be activated in other organisms. For example, in human body, these conditions are not available. Even if you take BT, it just passes through the intestine and it will be excreted. BT is like a specific medicine. It is not a general poison as it is made out to be. For example, if a person is suffering from roundworm, and if he goes to a doctor prescribes him some medicine for deworming. And if he takes that medicine, it is only the worms that will be killed, but not the patient. Otherwise, it makes no sense. In this case also, BT that is incorporated in cotton plants, it will kill only the bollworms, not the other organisms, and it will not cause any damage to the pest. So this has to be realized by those who are opposing this technology. BT has an impeccable safety record, either as a spray or for the last 18 to 24 years, it has not caused any harm to anywhere for anything anywhere in the world. And major scientific organizations which have examined the safety data all over the world, they have declared that BT is very safe. BT cotton and also the other GM products are very safe. So we have to go by the recommendations of the scientific findings, because after all, BT is a scientific product. But such recommendations and such experimental results have absolutely had no impact on the opponents. They are unrelenting. Even in the early stages itself, they made several allegations, but even after 18 years, they made the same old allegations during a webinar, which was held recently on 24th August 2020. They said BT is harmful to humans, animals, and damage the soil. As I've already mentioned, the safety of BT has been proved beyond doubt, and it is very specific in its action. Another allegation was that it caused losses to farmers, leading to increased incidents of suicide. This is a very cruel statement, because BT farmers have been immensely benefited by this technology, and they are better off socially and economically. And they are very happy, and no one commits suicide out of joy. And another allegation was that it was very funny. One scientist mentioned that BT is like any other synthetic chemical pesticides, and it is meeting the same fate as them. It is a very unscientific and wrong comparison. BT is a biopesticide with host specificity. It is not a general poison. And the same scientist said that BT technology is aging. Yes, BT has been there for nearly 24 years, but it is still preferred by the farmers, which is a testimony to its benefits. And there was another scientist who said that BT technology is not required in India at all. He said, if we undertake high density planting of local varieties, it will take care of everything. I'm not able to understand how high density planting is going to take care of the pests. You need technology to control bollworms and other pests. By merely planting them, you're not going to take care of them. You have to use some technology. And why use unnecessarily other technologies when such a beautiful technology is available? So if BT technology is combined with high density planting, it's a win-win situation for both. There is no fun in discarding a technology which is very highly beneficial. At the same time, scientists made another statement. He said, increase in yield in India was due to increased application of fertilizers, not due to BT cotton. We know that fertilizers do contribute to plant growth, but we also know that fertilizers do not offer protection against pests, which is a major concern. Yield increase in BT cotton was mainly due to bollworms, and it is due to BT. Other factors also contributed. No need to go out of the way to take away the credit with statistical jugglery, because BT has done its job. And this is very evident. If you take a look at this graph, it is very evident that the blue bars, they represent the yield. Until 2002, the yield was less than 300 kg per hectare. After the introduction, it went even beyond 500 kg. And similarly, the production, which is shown in red, it was very low until the BT technology was introduced, and then it jumped. And as a result, India actually turned from an importer of cotton to an exporter of cotton. So when a technology has made that kind of a contribution, why unnecessarily sidetrack it? It is not desirable. Of course, in society, there are those who are specialized in finding fault even with the best. And if they cannot do the best themselves, they try to destroy or take away the credit from the best. They spread negativity, which is not desirable. There are several things for us to do. We have to look forward. We have to develop a technology in order to see that the pink bollworm resistance is overcome. Efforts are already being made in this direction. And we have to develop new products for bollworm control to replace the existing ones in case the pests develop resistance to them, which is again already underway. Make full efforts to develop technologies to control cyclic pests, which we are lacking now. Another thing is, there is no to be biased towards any particular technology. Each has its own place, and we have to standardize integrated pest management. For example, for control of pests, including bollworms, we have a number of technologies available to us. Each has its own merit and limitations. The best thing for us is to make judicial integration of all technologies available to us so as to manage the pests. So that is what is called integrated pest management. In integrated pest management, we have to use our wisdom. Integrated pest management is also intelligent pest management, which is IPM. With all said and done, BT cotton has benefited all stakeholders. It has benefited the farmers, it has benefited the consumers, it has benefited the industries and the seed, especially the seed industries, and it has benefited scientists, government, and more than anything else, it also benefited the opponents. In the name of opposing it, they have been able to prosper. BT technology is here to stay as long as the farmers want it. So with this, I would like to conclude. Thank you very much.
Thank you, Dr. Manjunath, for taking us through an array of comments made by you, having observed the introduction and growth of BT cotton in India, and also trying to answer many of the allegations you've made. Hopefully, some of these messages that you've given will be accepted, will be agreed upon, and then so that we can move forward together. Once again, thank you so much. Thank you very much. Friends, I now would like to introduce two more farmers. One is, if I can get the name right, I apologize if my pronunciation is wrong. He's from Tamil Nadu, Mr. Keesagaram Kannan. He will speak in Tamil, but we've tried to get some subtitles in English so that people who don't understand Tamil will be able to read exactly what he's trying to say. And then after that, we have a farmer, extremely excited to introduce Mr. Sudhanshu Kumar from Bihar. Now we've gone to Bihar, so we've been to Rajasthan, been to Haryana, now we're going to Tamil Nadu, and then after that to Mr. Sudhanshu Kumar in Bihar, and that will be in English. Thank you very much. Mr. Kannan, please take it away.
சிக்கிராரக்கட்டளையிலிருந்து கண்ணன் பேசுகிறேன். சிக்கிராரக்கட்டளை திருவாரூர் மாவட்டம், தமிழ்நாட்டில் சென்றது. நான் கடந்த ஒரு 36 ஆண்டுகளாக விவசாயம் செய்து வருகிறேன். இதில் கடந்த ஒரு 20 வருடங்களாக பருத்தி விவசாயம் செய்து வருகிறேன். இதில் பருத்தியில் பொறுத்தவரை இப்போ என்னுடைய பார்த்தீங்கன்னா இந்த சரௌண்டிங்கில் இருக்கிறது என்னுடைய வயல்கள் தான். இங்கே கூட இருக்கிறவங்களாம் என்னுடைய விவசாய நண்பர்கள் எல்லாருமே பருத்தி விவசாயம் பண்ணுறோம். இதில் பருத்தி விவசாயத்தை பொறுத்தளவு ஏற்கனவே நாங்கள் இப்போ பிடி காட்டன் பண்ணுறோம். குறிப்பாக ஆர்சிஹெச் 659 ரகம் தான் இதெல்லாம். இதில் இன்னொரு இது என்னென்னு கேட்டிங்கன்னா, ஏற்கனவே நாங்கள் ஆரம்ப காலங்களில் நான் பிடி அப்படிங்கிற வெரைட்டி ரகங்கள் இதை பயன்படுத்திட்டு இருந்தோம். அப்போ அந்த வெரைட்டி ரகங்களில் எங்களுக்கு என்னன்னு கேட்டிங்கன்னா, வயல் ரெண்டுக்குமே ஒரே அளவு தான். பருத்தி விதையை பொறுத்தளவு இந்த ரகங்களுக்கு ஒரு 4.5 கிலோலேருந்து 6 கிலோ வரையும் விதை தேவைப்பட்டது. ஆனால் இப்போ பிடி காட்டன் எடுத்துக்கிட்டிங்கன்னா சாதாரணமாக அவங்க ஒரு பரிந்துரை ஒரு 450 கிராம். நாங்கள் விவசாயிகளாக செய்யும் பொழுது ஒரு 900 கிராம் அளவுக்கு அதிகபட்சமாக 900 கிராம் விதையை பயன்படுத்துகிறோம். அதே சமயம் நான் பிடியை பொறுத்தளவு, அதாவது வெரைட்டி ரகங்களை பொறுத்தளவு 2x1 அப்படிங்கிற இடைவெளியில் தான் பயிர் செய்வோம். இந்த நான் பிடியை பொறுத்தளவு 3x3ங்கிற இடைவெளியில் சாகுபடி செய்து வர்றோம். இந்த 2x1 செய்யும்போது அதுக்கான விதைகள் 8 கிலோ வரைக்கும் தேவைப்படுது. இப்போ 3x2 அப்படி 3x3 செய்யும் பொழுது விதையினுடைய அளவு எங்களுக்கு ஒரு 400 என்ன ஒரு சதவீதம் கேட்டிங்கன்னா, நாங்கள் ரகங்கள் போடும் பொழுது அது 100% களை வெட்டுறது, பார் அணைத்தல் எல்லாமே 100% மேனுவல் தான், ஆட்கள் தான், கூலி ஆட்கள் கொண்டு தான் செய்யணும். ஆனால் அதே சமயம் இந்த 3x3ன்னு நாங்கள் பிடி காட்டன் போடும் பொழுது 90% வேலைகள் கைவண்டி மூலியமாக, பவர் டில்லர்னு சொல்கிறோம்ல, அந்த கைவண்டி மூலியமாக நாங்கள் செஞ்சுறோம். அதாவது உழவு ஓட்டுதல், அப்புறம் குறுக்கு இடைகளை வெட்டுதல், இது எல்லாமே கைவண்டி மூலியமாக செய்கிறோம். அதில் எங்களுக்கு ரொம்ப வெகுவான அளவுக்கு பணம் செலவு குறையுது. அதோடு மட்டும் இல்லாமல் இந்த காலங்களில் கிடைக்கக்கூடிய வேலையாட்கள் பற்றாக்குறையையும் நாங்கள் ஈஸியாக சரி செய்ய முடியுது. அதோடு மட்டும் இல்லாமல் அதனால தான் நாங்கள் அதிக அளவிலான பருத்தியை கூட சாகுபடி செய்யறதுக்கு காரணம் இந்த பிடி காட்டன் தான். இந்த பிடி காட்டன் சாகுபடி பண்ணுறதுனால தான் நாங்கள் பரப்பளவு கூட பண்ண முடியுது. இது ஒரு பக்கம். அடுத்தது ரகங்கள் எடுத்துக்கிட்டிங்கன்னா, நம்ம ஆரம்பத்தில் எடுத்திங்கன்னா குறைந்தபட்சம் ஒரு வாரத்துக்கு ஒரு நாள், அதாவது வீக்லி அல்லது ஃபோர்ட் நைட்லி ஒரு மருந்தை கொடுத்துக்கிட்டே இருக்கணும். மருந்து அடிக்கலைன்னா எடுத்து முடிகிற வரையும் மருந்து அடிச்சே ஆகணும். அப்படி மருந்து அடிக்கலைன்னா நிறைய பூச்சி ஆரம்ப காலகட்டங்களில் சாறு உறிஞ்சும் பூச்சிகளான பேனு, ஜாஸ்திட்டு ஆஸ்பிட்ஸ் வரும். அதுக்கப்புறம் பார்த்தீங்கன்னா காய்ப்புழுக்கள் நிறைய, அதாவது குறிப்பாக சொல்லணும் பிங்க் போல்வாம் ரொம்ப கடுமையான பாதிப்பு உண்டக்கூடியது. அதனால் அந்த புழுக்களோட போராடி தான் நாங்கள் பருத்தி எடுக்கணும். அதனால வந்து செலவுகளும் நான்பிடியில் ரகங்களுக்கு அதிகப்படியான செலவு பிடிக்கும். இப்போ வந்து இந்த பிடி ரகங்களில் காய்ப்புழுவே வரல அப்படிங்கிற அளவுக்கு பிடி ரகங்கள் உருவாக்கப்பட்டதுனால எங்களுக்கு வந்து ஆரம்ப கட்டத்தில் 1-2 மருந்து இந்த சாறு உறிஞ்சும் பூச்சிகளுக்காக அடிக்கிறோம். அப்புறம் ஒரு காலகட்டங்களில் சப்பாத்தி பூச்சி அகப்பந்து இந்த வயலை பார்த்தீங்கன்னா நான் இதுவரை வந்து ஒரு முறை பருத்தி எடுத்துக்கேன். எடுத்தது இதுவரையும் வந்து இந்த பயிரில் ஒரே ஒரு முறை மட்டும்தான் சாறு உறிஞ்சும் பூச்சிகளுக்காக மருந்து அடிச்சிருக்கேன். மற்றபடி எந்த பூச்சிகளும் எனக்கு தொந்தரவு இல்லை. இது ஒரு முறை எடுக்கப்பட்ட பருத்தி மறுமுறை பார்த்தீங்கன்னா 2வது பாருங்க நல்ல தரமாக இருக்குது. ஏற்கனவே ஒரு ஏக்கருக்கு வந்து 16 குவிண்டால் வந்து எடுத்துருக்கேன். 15லேருந்து 16 குவிண்டால். இன்னும் வந்து இந்த பருத்தி எடுத்தோம்னா இன்னொரு 10 குவிண்டால் வரும். ஒரு ஏக்கருக்கு 20 குவிண்டாலுக்கு மேலே 25 குவிண்டால் வரையும் மகசூல் எடுக்கலாம். இப்போ நாங்கள் உழவு பற்றி சொல்லும்போது பார்த்தீங்கன்னா டிராக்டர் உழவுக்கும் இதில் எல்லாம் வேலை செய்யறதுனால ஆள் செலவு எங்களுக்கு மிச்சம். அடுத்தபடியாக மருந்து அடிக்கிறது எடுத்துக்கிட்டிங்கன்னா இது 1-2 மருந்து அடிக்கிறது மட்டும்தான். அதனால எங்களுக்கு வந்து இந்த பருத்தியை பொறுத்தவரை பிடி காட்டனை பொறுத்தவரை செய்யறது இதாக இருக்கும். இது 689 ரகம் எங்களுக்கு நல்ல மகசூல் கொடுக்கக்கூடியது எங்கள் பகுதி நாற்றுங்கிறதுனால. இதோட மட்டும் இல்லாமல் இப்போ இந்த விவசாயத்தை பொறுத்தவரை இந்த பருத்தி சாகுபடிக்கு வந்து உறுதுணையாக இருக்கிறது வந்து இந்த பிடி காட்டன் தான். பிடி காட்டனால தான் எங்களுக்கு காய்ப்புழுக்கள் தொந்தரவு இல்லாததுனால மகசூலும் கூட வருது. அதோட மட்டும் இல்லாமல் இப்போ பார்த்தீங்கன்னா இந்த பிடி காட்டன் போடுறதுனா என்னுடைய ஒரு பையன் இன்ஜினியரிங் படிச்சிருக்காப்புல, இன்னொரு பையன் விவசாயத்துறையில் படிச்சுட்டு இருக்காப்புல. இதுக்கு வந்து இந்த பிடி காட்டன் போட்டதுனால மட்டும்தான் என்னால் இதை இது பண்ண முடியும். அதோட இல்லாமல் நாங்கள் இது வந்து இன்னும் சொல்லப்போனால் ரைஸ் ஃபாலோ காட்டன்னு சொல்லுவோம். அதாவது நெல் அறுவடைக்கு பிந்தைய பருத்தி. இந்த பருத்தி ரகங்களை வந்து நாங்கள் பண்ணுறதுனால எங்களுக்கு 2வது பாகமாக இது பண்ணுறதுனால நல்ல மகசூல் வர்றதோட மட்டும் இல்லாமல் எங்களுக்கு விவசாயத்தில் எளிமையான ஒரு இதுவும் கிடைக்குது. நாங்கள் என்ன சொல்ல விருப்பப்படுறோங்கன்னா இப்போ ஏற்கனவே வந்து இந்த பிடி காட்டனில் அதாவது காய்ப்புழுக்களே வராத அளவுக்கு ரகங்கள் கண்டுபிடிச்ச மாதிரி வருங்காலத்தில் இந்த சாறு உறிஞ்சி பூச்சிகளும் தாங்கி வளரக்கூடிய பருத்தி ரகங்களை கண்டுபிடிச்சி கொடுத்தீங்கன்னா எங்களுக்கு மருந்துங்கிற தேவைகளே இல்லைங்கிற அளவுக்கு வரும். கண்டிப்பாக மன உளைச்சலும் கிடையாது, நல்ல மகசூலும் கிடைக்கும். அதுக்கான வழிவகைகளை யார் செஞ்சு கொடுத்தாலும் விவசாயிகளுக்கு நாங்கள் அனைவரும் அவர்களுக்கு நன்றி உடையனாக இருப்போங்கன்னு சொல்லிட்டு இதுக்கு ஒரு வேறு ஏதாவது இன்னும் ரகங்கள் புதிய ரகங்கள் இந்த எடுக்க ஆளுக்கு இருக்கிறது அதுக்கு ஏதாவது நல்ல அட்வான்ஸ்டு மெசேஜ் எல்லாருக்கும் பயன்படுற மாதிரி அது ஒரு ஹையர் கைடு அந்த மாதிரி வர்ற மாதிரி செஞ்சுருந்தா இன்னும் நல்லா சௌரியமாக இருக்கும். போதுமானது.
Hello everybody, my name is Sudhanshu Kumar. I am a farmer from a district called Samastipur, which is in Bihar. I am a postgraduate from Hansraj College, Delhi University. We are 3 brothers. 2 of us are doing farming. One is an orthopedic surgeon. My son has just finished his final semester doing BTech IT from Manipal. My wife's a professor in English. Traditionally, we are a farming family. My father in the early 70s had a very modern seed processing plant, and he used to grow seeds for wheat and maize. My grandfather bought his first tractor, a Caterpillar, in 1952, and another tractor, a John Deere, in 1954. As a farmer, I understand the importance of technology in agriculture. And today, as a farmer, I would like to give you my view on GM technology. Invariably, whenever we talk about GM technology, we end up talking about BT cotton. This sort of regionalizes GM technology. We have to change this perception of farmers. We have to impress upon farmers that GM technology can be useful for every crop. It can do wonders no matter which crop we are doing. There is no doubt that in agriculture, tremendous amount of technology has come in. But without GM technology, it is like driving a modern car with wooden wheels. I, as a farmer, have always embraced technology. In this farm that I'm standing in, we have complete automation of fertigation. My laptop is attached to my system. My mobile is attached to my laptop through TeamViewer. And No matter where I am, I can control the irrigation of this orchard. We have broadband right out here to the field. And we are talking to a company for farm ERP, electronic resource programming, because we want to do soil mapping by drone. We want to QR code all our trees. In fact, we are trying to use blockchain in our fruit supply. Even one of the farmers of this Pro Agri Science Association that we have has developed a robo-arm for picking cotton. Why am I saying all this? Technology, technology, technology. But no GM technology. GM technology is the silver bullet for the problems of farmers. Countries like Bangladesh have adopted BT brinjal. Countries in Africa, the governments have made bold decisions to go GM. They are trying to leapfrog and become one of the best agricultural countries. We are still lacking behind. And I would like to give you 3 examples of Bihar. From Bihar. Number 1, I remember every household in Bihar always had at least 4 to 5, 6 papaya trees in the backyard. Today, you will not find a single papaya tree in Bihar. Some people who are trying to do it commercially fail after 12 months or 14 months because they can't get rid of the fungus in the soil. And what happens? Commercially viable, this wonderful fruit that can give a farmer such a good return, they cannot do it. And I know GM has a solution to this. My second example will be lentils. Bihar, this land both sides of the Ganga, the huge pulse growing area. Farmers have no other choice but to grow pulse. And the amount of fungicide, the amount of pesticides they use to get rid of this wilt and the pod borer worm. And still, after doing all that, they still get around 1/3 of the produce. And I know GM has a solution for this. If a solution to this could be taken out, I think Bihar will become self-sufficient in pulses. And why Bihar? I think we can supply whole of India with ample amount of pulse. Here, we need GM technology. My third example will be corn. We all know that Bihar is the largest supplier of Rabi corn in India. Just imagine with GM technology, the amount of input costs we could reduce. Weedicide, nitrogen, number of irrigation, the fallworm, which we've all experienced this year. And I know countries which are using GM corn, they have nothing to worry about the fallworm. So technically speaking, if we could get GM technology, at least in Bihar, it would change the face of agriculture. Why we waited so patiently for solutions? We've been given the multinational bogey that we lose control. But how long are we to wait? GM technology is the need of the hour. GM technology is a technology that is a must for farmers. We should demand GM technology. It's time the government gave us GM technology. Thank you.
Thank you so much. There was a very clear presentation by both farmers. Mr. Kizagaram Kannan from Tamil Nadu, standing right in his field. I really appreciated how he followed the COVID-19 prevention guidelines. He had his fellow farmers, he had his family there. He had followed social distancing, and he was also wearing masks. I also appreciate Mr. Sudhanshu Kumar, who did narrate in such a lucid and eloquent manner what is really required. He's a pro-technology man. He can have access to all other kinds of technologies, but not necessarily what is best for some of his crops, which could be GM technologies. So thank you very much, both Mr. Kannan and Mr. Sudhanshu Kumar. We'll go to the third scientist in this group of scientists that we have, Dr. Anand Kumar. Dr. Anand Kumar, I've known him for quite a few years now. I know he's very, very active in the area of agriculture as a research scientist and also in touch with farmers. He got his PhD in plant physiology from Indian Agricultural Research Institute, New Delhi, that's IARI. He did his postdoctoral research in University of Hanover as a Humboldt Fellow, that's in Germany. He's made phenomenal contributions in the area of BT biology, vis-a-vis entomology, biochemistry, gene prospecting, gene construction, biophysics, and transgenic plants. I'm sure he knows the safer side of how this GM technology can play a role when it's applied to crops. Because he's a scientist, he's a molecular biologist, he would know what he's trying to do. He also excelled in functional genomics of cotton, brinjal, flax, and rice. And I think he had a role in developing a BT brinjal or an event of BT brinjal. He's editor of GM Crops and Food. He's a member of GEAC, RCGM, MEC, and several other committees in the Departments of Government of India. I don't know if he still is a member, but he did serve many years. Now I would like to pass over the controls to Dr. P. Anand Kumar in Hyderabad. Thank you so much.
Thank you, Dr. Jagdish. At the outset, I would like to express my gratitude to Biotechnica and Agri-Science Forum for giving me this opportunity. The regulation of GM crops or GE crops in India comes under Environmental Protection Act, 1986. And the rules have been formulated in 1989. So they are called Rules 1989. And 5 different government committees at state level and central level are responsible for implementation of Rules 1989. Next slide. The genetic engineering crops regulatory system flowchart is given in this slide. The different steps start initially from the Institute Biosafety Committee at the institute level or university level or the company R&D company level. And the flow chart, as you can notice, ends up at the Genetic Engineering Appraisal Committee, which is located in the Ministry of Environment and Forests. Next slide, please. The first GE crop, that is BT cotton, has been approved for environmental release in the year 2002. The whole process started in 1996 when a Mexico company imported 100 grams of seed of BT cotton cocker variety and started introgressing the event in their commercial hybrids. And ultimately in the year 2002, 3 hybrids have been approved by GEAC for commercial cultivation. It took about 6 years. Next slide, please. The company has taken the help of many public research institutions in ICAR, CSIR, ICMR, and Agricultural Research Institute and universities to undertake all these biosafety and environmental safety tests, which range from skin irritation of foreign protein, immunogenicity, and so on and so forth. Next slide, please. So in the year 2002, as I have mentioned earlier, the MON 531 event that expresses BT insecticidal crystal protein Craven AC has been commercialized, approved, and subsequently 5 different events submitted by various companies and institutes have also been approved by GEAC. And recently, in the year 2017, 8 varieties that express event MON 531 have been approved. And these have been developed by Central Institute of Cotton Research and state agricultural universities like Punjab Agriculture University. Next slide, please. So in the past few years or a decade, a few changes and modifications have been done in the GE crop regulatory system, starting with, let us say, nomenclature. The Genetic Engineering Approval Committee has been renamed as Genetic Engineering Appraisal Committee. The multi-location research trials have been renamed as Biosafety Research Level 1, and large-scale testing has been renamed as Biosafety Research Level 2. And the important thing is all biosafety tests, environmental safety tests, should be completed by the end of Biosafety Research Level 1. And another more important thing is there has been an introduction of a requirement for no objection certificate from various state governments wherever the trials are supposed to be conducted. And this has been made in the year 2011. And recently, the GEAC has given exemption to event selection trials conducted either on the institutes or companies or universities' own farm or in farm leased from the farmers for 3 years. So this is an important change that can be seen. Next slide, please. So all the guidelines of GE regulatory system have been notified in various websites, as you can see in this slide. All the guidelines, standard operating procedures, rules, and regulations can be accessed from these websites. Next slide, please. So in the past 7 or 8 years after the introduction of events like Bolga 2 and EE1, then Event 1, and so on and so forth, there have been other events that have been submitted to the Indian GE regulatory system. And these events in BT cotton, in fact, have completed biosafety research level 2 in the case of white strike that expresses 2 genes and developed by Dove Agro Company. And also herbicide tolerant cotton or herbicide tolerant Bolga 2 also has been subjected to the regulation and completed the BRL2 trials. But the company, the technology developer Monsanto, has withdrawn glyphosate tolerant BT cotton Bolga 2 from the regulatory system. Elsewhere in USA and Australia, 4 novel events have been commercialized. For instance, you can see number 1, White Strike 3, that expresses 3 different BT proteins that differ from mechanism of action. And this has been developed by Dove Agro and is commercial in USA. Similarly, Bolgard 3, again, a novel gene has been added to Bolgard 2, that is vegetative insecticidal protein from Bacillus thuringiensis, and it has been commercialized in Australia and USA. Similarly, BASF has commercialized Twin Link Plus, very similar to Bolgard 3 or White Strike 3, but this carries Craven AB, Cray2 AE, and vegetative insecticidal protein, and this is approved in USA. And in the recent past, Bayer or Monsanto has developed BT cotton resistant to lygus bugs, expressing a novel BT insecticidal protein by name Cry51AA2. And the scenario in India is, in the past 8 or 9 years, National Botanical Research Institute, in collaboration with the JK Agri Genetics, has developed a dual BT gene carton that expresses Craven EC and Craven AC. And the status of this event is not known. The Tamil Nadu Agricultural University in Coimbatore has discovered its own gene from BT known as Cray2AX, mobilized in cotton, and this has been undergoing glasshouse testing. Similarly, Punjab Agricultural University in Ludhiana has expressed VIP gene along with an onion lectin gene for resistance against Helicobacter pyrgera and whitefly. Now it has been undergoing glasshouse testing. And very recently, the National Botanical Research Institute in Lucknow has developed cotton, GG cotton, expressing a fern gene by name TMA12. This gene confers resistance against whiteflies, a very, very important trait we all need in GG cotton, or rather protection of cotton. Thank you very much. Next slide, please. Okay, in the past 1 decade or so, we have noticed that pink bollworm or Pectinophora gossypiella has developed resistance to Bolgard 1 as well as Bolgard 2. And it has become a severe menace in the past 4 to 5 years. And admittedly, or frankly speaking, the failure of BT cotton versus pink bollworm is because of very lax stewardship on the part of, let us say, starting from the technology developer, the licensees, the institutions, the universities, state agriculture departments, and of course, ultimately the farmers. And things haven't been really helped by anti-GM lobbies who have created all kinds of hurdles, impediments for a development and infusion of new technologies in BT cotton. That is another very important parameter we have to consider. Otherwise, in the past 5 or 6 years, new BT cotton events, improved BT cotton would have been released and the farmers would have enjoyed the benefit of resistance to pink bollworm. In fact, it has happened in USA, it has happened in China. Pink bollworm has developed resistance in both these countries, but they could manage pink bollworm because they have approved novel, improved BT cotton events. And the need of the hour is there should be an active participation, collaboration between farmers, institutions, and NGOs to sort out this problem. In this context, the efforts of NGOs like South Asia Biotechnology Network are really praiseworthy. And I also should mention, in the past 4 or 5 years, novel BT genes like Craven C and Craven D, which are effective against pink bollworm, have been discovered and tested against pink bollworm larvae in laboratory. Next slide, please. In addition to these novel genes, we also have several novel technologies like RNA interference and genome editing by CRISPR-Cas. One example is Chinese Academy of Sciences, in collaboration with the University of Arizona, has developed a BT carton event that combines a BT Craven-AC gene with RNA-I interference. And this RNA-I silences juvenile hormone methyltransferase in the Helicobacter pyrgera, that is cotton bollworm. Similarly, Chinese Academy of Sciences have also employed RNA-I silencing to interfere with the P450 monooxygenase, thus making the cotton bollworm susceptible to gossypol in cotton, which is present in cotton. Similarly, the latest technologies like genome editing have unraveled the mechanisms of resistance to Bt in insect larvae, in insect pests. And we know now what are the exact receptor proteins and what are the exact mutations that have occurred in the insect pests like Helicoverpa amigera. So based on this, one can do genome editing in Bt cotton, editing of Bt genes that are already existing, so that the Bt proteins will bind to the insect pest receptor much more efficiently and kill the insects. So this is a very, very forward-looking, futuristic technology we could have and should have developed by now. Next slide, please. So, as I mentioned in the past few slides, some of the important impediments for deployment, implementation of these new technologies and novel genes in Bt cotton stem from the initial decade-old moratorium imposed on Bt brinjal in 2010, which has disillusioned, disappointed, and paralyzed scientists and technology developers in public research system as well as in corporate sector companies. Not only that, and we have noticed in the past few years, there has been a weak protection to intellectual property rights in India, and also some trade issues related to royalties, and which has not been have not been very encouraging to the companies that want to commercialize new technologies. And the requirement of no objection certificate by state government has virtually stonewalled each and every new technology, each and every new event. Unfortunately, most of the state governments refuse to issue no objection certificate because the state governments and the administrators have been scared, have been terrified by false propaganda and also by spreading lies and canards about GE, GM crops, biotechnology, and insect resistant crops in specific. And this strident anti-GM propaganda, anti-GE propaganda has done enormous harm to the agricultural unveiling of new agricultural technologies, and also farmers unable to get new technologies and get benefit from the GE crops. And if the state governments resist the pressure of anti-GM groups and lobbies and encourage the public institutions and also private sector institutions by issuing no objection certificates, the technology will go forward and we can sustain the benefits of genetic engineering cotton or Bt cotton or whatever for a long time to come. Thank you very much.
Thank you, Dr. Anand Kumar, for taking us through what it really takes and the hard work that is done behind to introduce a biotech crop in India. You've taken us through the flow chart of the various committees. There may be scientists and others involved who have gone through the data and how they've come forward to recommend approval of a particular Bt or otherwise GM crop. You also made reference to opportunities available for controlling other pests. It could be biotech answers or it could be agronomic aspects. So there are opportunities available to control other pests that are beginning to attack a cotton crop or any other crop, for instance. Your discussion led a very positive flair to this whole topic. And the only negative that has come out is to see how there are other challenges there are. But again, you became very positive, saying that there are opportunities available to address those negative aspects. So thank you so much, Dr. Anand Kumar. And now I would like to connect you to more farmers. I'm extremely excited, reaching out to the farmers. And at this stage, I must pay regards to Mr. V. Ravichandran, who is the founder of the Pro Agri Science Forum, where a lot of farmers and scientists and other technologists interact on a day-to-day basis, a WhatsApp group and a Telegram group. So far, because of his help and because of his connectivity to hundreds of farmers, not only in India, but outside of India as well, we were able to listen to farmers from Rajasthan, Haryana, Tamil Nadu, and Bihar. Now, it's my pleasure to take you to farmers from other states. And to start off, we have farmer Mr. Sudhindra Kulkarni from Karnataka, northern part of Karnataka, and Mr. Ganesh Nanote from Maharashtra. And we have Mr. Velankini Reddy from Telangana state, and Mr. Umesh Chandra Debanath from West Bengal. Friends, there were many other farmers who also wanted to speak out on this forum. Unfortunately, because of the time factor, we had to limit the number. But I will assure you, going forward, with the help of forums like Biotechnica, platforms like Biotechnica, and others, we will be able to bring you the words straight from the farmer's heart itself. And we also had farmers from other countries reaching out to us. We had a farmer from Kenya, and we had a farmer from South Africa. Unfortunately, we could not connect to them again because of the time factor. Hopefully, we'll be able to do so. Now, it's my pleasure to take you over to farmer Mr. Sudhindra Kulkarni from Karnataka. Following him, Mr. Ganesh Nanote from Maharashtra. Following him, Mr. Velankini Reddy from Telangana state. And Mr. Umesh Chandra Debanath from West Bengal. Thank you.
ನನ್ನ ಹೆಸರು ಸುಧೀಂದ್ರ ಕುಲಕರ್ಣಿ ಅಂತ. ನಾನು BT ಹತ್ತಿ ಬೆಳೆಗಾರ. ಯಾವುದೋ ಒಂದು ವೈಯಕ್ತಿಕ ಕೆಲಸದ ಸಲುವಾಗಿ, ಒಂದು ಅಗ್ರಿಕಲ್ಚರ್ ಸಲುವಾಗಿ ನಾನು ಬೆಂಗಳೂರಿಗೆ ಬಂದಿದ್ದೆ. ಸೊ BT ಹತ್ತಿ ನಾವು ಆ್ಯಕ್ಚುಲಿ ಅಂತಂದರೆ ಮೂಲತಃ ನಮ್ಮದು ಊರು ಜೇವರ್ಗಿ ತಾಲೂಕು, ಮಳ್ಳಿ ಗ್ರಾಮ, ಯಡ್ರಾಮಿ ತಾಲೂಕು, ಗುಲ್ಬರ್ಗ ಜಿಲ್ಲೆ, ಕರ್ನಾಟಕ. ಸೊ ನಾನು ಆ್ಯಕ್ಚುಲಿ ಅಂತಂದರೆ ನನ್ನ ಫಾದರು, ಅವ್ರ ಫಾದರ್ ಇವರೆಲ್ಲ ಮೊದಲು ಏನು ಮಾಡ್ತಿದ್ವಿ ಅಂತಂದರೆ ದೇಸಿ ಹತ್ತಿನೇ ಬೆಳಿತಿದ್ವಿ. ಅವಾಗ ಏನಾಯಿತು, ದೇಸಿ ಹತ್ತಿಯಲ್ಲಿ ಒಂದು ರೇಟ್ ಇಲ್ಲ, ಇಳುವರಿ ಇಲ್ಲ. ಆಮೇಲೆ DCH ವರಲಕ್ಷ್ಮಿ ಹತ್ತಿ ಕೊಡ್ತು ಯಾವುದು ಸರ್ಕಾರ. ಬಟ್ ಆ ಒಂದು ಹತ್ತಿನ ನಾನು ಬೆಳೆಯೋಕೆ ಹೋಗಿ ಮುಂಚೆ ಏನಾಯಿತು, ಹುಳುಗಳ ಬಾಧೆ. ಹಿಂಗಾಗಿ ಕಾಂಡ ಕೊರಕ, ಕಾಯಿ ಕೊರಕ ಹುಳುಗಳು ಆದಾದ್ಮೇಲೆ ಅದು ಏನಾಗಿಬಿಡ್ತು, ಇದ್ರದ್ದು ಇಳುವರಿ ಬರಲಿಲ್ಲ. ಹಿಂಗಾಗಿ ಲಾಸ್ ಆದ್ವಿ. ಲಾಸ್ ಆಗಿ ಅದಕ್ಕೂ ಡಿಸೀಸು ಅದು ರೋಗ ಎಲ್ಲ ಬರ್ತಿತ್ತು. ಹಿಂಗಾಗಿ ಲಾಸ್ ಆಗಿಬಿಟ್ಟು ನಾವೇನು ಮಾಡಿದ್ವಿ, ಹತ್ತಿ ಬೆಳೆಯೋದೇ ನಿಲ್ಲಿಸ್ಬಿಟ್ವಿ. ಯಾವಾಗ ಭಾರತದಲ್ಲಿ BT ಹತ್ತಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆಯಿತು, ಆವಾಗ ನಾವು ಒಂದು 2 ವರ್ಷ ನಮಗೂ ಒಳಕಿತ್ತು. ಆಮೇಲೆ ಬರ್ತದ್ದು. ಇವತ್ತು ನಾನು ವೆರಿ ಹ್ಯಾಪಿ. ನಾನು ತುಂಬ ಚೆನ್ನಾಗಿ ಬೆಳೀತಾ ಇದ್ದೀನಿ. ಪ್ರತಿ ಎಕರೆಗೆ ನಾನು 22-23 ಕ್ವಿಂಟಲ್ ಒಂದು ತೊಗೊಂಡಿದ್ದೀನಿ. ಸೊ BT ಕಾಟನಲ್ಲಿ. ಆದ್ರೆ ನಂದೇನು ಈ ಒಂದು ವಿಡಿಯೋ ಮೂಲಕ ಸಂದೇಶ ಕಳಿಸೋದೇನಂತಂದರೆ, BTಯಲ್ಲಿ ತುಂಬ ಇದೆ. ತೊಗರಿ ಇದೆ, ಕಡಲೆ ಇದೆ, ಇನ್ನು BT ಬೋರ್ಗಾಡ್ 3 ಅಂತ ಏನೋ ಇದೆ ಅಂತೆ. ಆಮೇಲೆ HD BT ಅಂದರೆ ಇದು ಹರ್ಬಿಸೈಡ್ BT ಅದೆಲ್ಲ ಸೀಡ್ಸ್ ಎಲ್ಲ ಇದೆ ಅಂತೆ. ಅವನ್ನೆಲ್ಲ ಸರ್ಕಾರ ರೈತರಿಗೆ ಕೊಟ್ಟರೆ ಇನ್ನೂ ಅನುಕೂಲ ಆಗ್ತದೆ. ಹಾಗಾಗಿ ರೈತನ ಆರ್ಥಿಕ ಸಂಕಷ್ಟ ನೀಗ್ತದೆ, ಇಳುವರಿ ಹೆಚ್ಚಿಗೆ ಬರ್ತದೆ. ನಾವು ದುಡ್ಡು ಏನಾದರೂ ಕಂಡಿದ್ರೆ ಅದು BT ಹತ್ತಿ ಬೆಳೆದ ಮೇಲೇನೆ ಹೊರತಾಗಿ ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಅಂತೂ इल्ले ಇಲ್ಲ. नमस्कार.
गणेश शामराव नानोटे, मुक्काम निंबारा, जिल्हा अकोला, इथला पारंपरिक कापसाचा शेतकरी. आम्ही जी शेती करतो ही पारंपरिक शेती. आमच्या कित्येक पिढ्यापासून ही शेती आमचे वडील पार्जित करत आले. आम्ही सुद्धा तेच शेती करत आहे. ही जी शेती आहे ही आमच्याकडे सर्वात जास्त शेती केली जाते, कापसाची शेती केली जाते. जेव्हा मी 91 मध्ये वडील वाढल्यानंतर शेतीवर आलो, तेव्हा जी पारंपरिक जी कापसा शेती होत होती तशी मी शेती करत होतो. त्याला आम्ही 8 ते 12 फवारण्या घ्यायचो. त्याचं पीक शेतामध्ये 10 महिने राहायचं आणि उत्पन्न केवळ फक्त 3 ते 4 क्विंटल यायचं. त्यामुळे खूप खर्च व्हायचा, वेळ खूप जायचा. दुसरं 2002-03 पासून एक नवीन तंत्रज्ञान आम्हाला मिळालं, म्हणजे BG1 मिळालं तेव्हा. तर त्या वर्षी मी पहिल्यांदा 2 एकर लावलं. ही त्याची चर्चा मीडियात झाली होती. काही लोक शेतकरी कृषी क्षेत्रात त्याची चांगली चर्चा होती, किंवा नवीन तंत्रज्ञानाला काहीतरी शेतकऱ्यांनी अनुभव घ्यावा म्हणून मी 2 एकरावरती लावलं होतं. त्या वर्षी मला चांगलं भरघोस उत्पन्न मिळालं. खर्च सुद्धा कमी आला होता, कारण की त्याच्यावर कोणतीच अडी आली नव्हती. मग मी दुसऱ्या वर्षी पूर्ण क्षेत्र जे काही मी त्या लागवड केली होती कापसाची, पूर्ण BT खाली आणली होती. त्याचा आम्हाला खूप फायदा झाला होता. आता BT मुळे तंत्रज्ञान आलं. मग त्याच्यापासून आमच्या घराचं जीवनमान उंचावलं, आर्थिक परिस्थिती सुधारली, मुलाचं शिक्षण असो, माझी सर्व मुलं शहरात शिकतात. हे कशामुळे झालं तर या तंत्रज्ञानामुळेच झालं, कारण की आम्हाला त्याचा चांगला आर्थिक फायदा झाला होता. आम्ही घर दुरुस्ती केली, शेतीमध्ये खूप काही योजना घेतल्या, पाईपलाईन खोदल्या, मोटारी बसवल्या, शेतीची दुरुस्ती केली. विशेष म्हणजे आमचं जे राहणीमान आहे हे खूप सुधारलं होतं. आम्ही चांगल्या दवाखान्यात आम्ही काम करायला म्हणजे जायला लागलो. म्हणजे आमच्या आरोग्यात सुद्धा चांगली आम्ही खर्च करू शकत होतो. ह्या गोष्टी बऱ्याचशा या बीटीमुळे झाल्या होत्या. पण मागच्या या 2-3 वर्षापासून सध्या परिस्थितीत चांगलाच आम्हाला किडीचा त्रास होत आहे. सर्वात मोठी कीड म्हणजे गुलाबी बोंडअळी. यामुळे आम्ही सध्या हवालदिल झालेलो आहे. त्यासाठी आम्हाला खूप काही खर्च येतो आहे. म्हणजे त्याच्यासाठी पहिली जी फवारण्या व्हायच्या त्याच्यासाठी आम्हाला 2 ते 3 फवारण्या आता आम्ही जास्त घेत आहे. आणि काही जे रस शोषक किडी आहेत याची सुद्धा प्रतिकार शक्ती वाढली. त्याला आता आम्हाला पहिल्यापेक्षा मागच्या 3-4 वर्षापासून जास्त खर्च करावा लागत आहे. ही एक आमच्यासाठी एक सध्या खर्चिक बाब ठरत आहे. दुसरं आता एक सर्वात म्हणजे आता मजुराची टंचाई आमच्याकडे खूप मोठ्या प्रमाणावर आहे. मजूर जर खूप खर्च मजूर म्हणजे तण काढण्यासाठी खूप खर्च करावा लागतं. जर तण नाही काढलं तर ते तण पिकाला स्पर्धा करतात. ते जमिनीतले जे म्हणजे अन्नद्रव्य आहेत ते शोषून घेतात. त्यामुळे आम्हाला त्याचा दुहेरी नुकसान होते. एक तर आमचे त्याला निंदण्यासाठी खर्च जास्त करावा लागतात आणि दुसरं म्हणजे पिकाचा जो वाढीचा किंवा त्याच्या आरोग्याचा परिणाम होतो. त्याच्यापासून ते पीक कमजोर होऊन जातं. त्यामुळे आपोआप उत्पन्नात घट होते. मागच्या काही काळापासून बाजारभाव कमी जास्त होतात. पण आमच्या शासनाने एक चांगली योजना आणली की त्यामध्ये आम्हाला हमी भावाने त्यांनी खरेदी करण्याची योजना आणली. त्यावर्षी आता आम्ही बरेचसे शेतकरी मागच्या काही काळापासून CCI असो किंवा महाराष्ट्र शासनाची योजना असो, हमी योजना, त्यामध्ये आम्ही कापूस विकतो. आणि बाहेर व्यापारी सुद्धा मोठ्या प्रमाणावर खरेदी करतात. जिकडे आम्हाला फायदा होईल तिकडे आम्ही बाजाराच्या जे अपेक्षित आहे तिकडे आम्हाला फायदा होईल तिकडे आम्ही माल विकतो. आता आम्हाला BG1 BG2 मिळालं. हे तंत्रज्ञान आमच्यासाठी चांगलंच होतं. पण याच्या भविष्यात जर याच्यापेक्षा म्हणजे तिसरं चौथं जनरेशन जर आम्हाला कदाचित मिळत असेल, आम्ही जागतिक क्षेत्रात स्पर्धा करू, आमचं उत्पन्न वाढेल, आमचा खर्च कमी होईल. म्हणजे आम्ही जागतिक स्पर्धेतला जो शेतकरी आहे, खूप उत्पन्न घेणारा शेतकरी असो किंवा त्यांच्या उत्पन्नाची आम्ही बरोबरी करू. ही आमच्याकडे तेवढी म्हणजे तंत्रज्ञान मिळालं तर आमच्यात पण तेवढी गुंतवता येईल. आम्ही त्यांच्यासोबत स्पर्धा करून आमचं उत्पन्न वाढवू. आता हेच पीक आम्ही सध्या आमच्याकडे कापसासाठी म्हणजे BG1 BG2 हे तंत्रज्ञान उपलब्ध आहे. याच्यापेक्षा जर भाजीपाल्यात खूप जो सर्वच ग्राहक वर्ग त्याचा भाजीपाला खातो, त्याच्यामध्ये तसेच डाळवर्गीय असो किंवा मका असो, यामध्ये खूप मोठ्या फवारण्या कराव्या लागतात किडीसाठी. हे जर फवारण्या कमी करता येईल, त्यामध्ये जर तंत्रज्ञान आलं तर बरोबर प्रत्येक जनतेच्या आरोग्याचा फायदा होईल आणि पर्यावरणाचा सुद्धा ऱ्हास कमी होईल. कारण की फवारण्या कमी कराव्या लागतील. त्यासाठी याची नितांत गरज आहे. मी सर्वात आम्हाला धन्यवाद देईल शासनाला की ज्यांनी प्रथम BG तंत्रज्ञान भारतात आणलं आणि आम्हा शेतकऱ्यांना उपलब्ध करून दिलं. ते जे कोणी शास्त्रज्ञ असतील त्यांना सुद्धा मी धन्यवाद देईल. आमच्यासाठी एवढं तंत्रज्ञान शोधून काढलं आणि आमचा फायदा केला. धन्यवाद.
Hi, my name is Valangan Reddy Mekala. Completed my BSc B.Ed in 1991. I am the member of Pro Agri Science group of farmers. I grow crops in 25 acres of land, as well as I am a poultry farmer also. I grow 85,000 broilers and 50,000 layers. So these are all my fellow farmers who are graduates also. We are all doing agriculture since last 20 years. We grow cotton, chili, maize and Bengal gram usually. Since 1992 to 2002, we were cultivating non-BT cotton. At that time, our economy was very bad. We used to spray 12 to 14 times at that time per the crop year. We used to spend 60 to 70% of the investment to non-BT crop to spray pesticides over it. In those years, some people who spraying persons fell down and getting ill and admitted into the hospitals, and some 2 or more people also died in our village due to the impact of these pesticides at that time. So we were not in a position to recover the investment which we invested in the crop year for the cotton. So we were not in a position to repay the bank loans also at that time up to 2001. In 1998 to 2000, in these 3 years, we stopped cultivating cotton crop also. Completely, we all farmers diverted to other crops like pulses and sunflower crop. When we were introduced to BT technology for the first time in 2001, we were given sample BT seed, just 1 acre for each. In our village, we got only 4 or 5 acres of BT cotton seed in 2001. We tried as a sample plots. That year it was amazing. At that time, we got those who planted BT cotton seed as a sample plots. We got 24 to 25 quintals per acre by spraying only 2 to 3 times of spray pesticides only for the sucking pest, not for the Heliothis and Spodoptera. In 2003, we were supplied a large quantities of BT cotton seed to the village and to the farmers. Then we have started cultivating in larger extents. Then we started enjoying the fruits of BT biotechnology in cotton also. Then since 2003 to till this year, we are very happy with this technology in cotton crop. By reducing investments in spraying pesticides over the crop to control Heliothis and Spodoptera, we are enjoying BT2 also, which controls not only Heliothis and but also Spodoptera also. So we were expecting actually Roundup Ready technology also, but government is not permitting. So we farmers, as farmers, we humbly request, please allow whichever technology, whichever is the latest one, whichever is the new one, which is applying in other nations, please allow the farmers to enjoy the fruits of biotechnology, whichever is the new one. Then only we can compete with the other farmers of the nations. This is the BT2 technology cotton crop. Its age is 3 months, 90 days. This is my maize crop, which is badly affected by fall armyworm. So for which I used to spray 3 to 4 times to control fall armyworm, which is the investment 60 to 70% of the investment of my total investment of this crop. Since last 2 years, we are being affected by this fall armyworm. Before that, we need not to spray single spray of pesticide also. At this time, it is very difficult to spray pesticides on the crop, but we can try to some extent to control this worm by spraying some pesticides when the crop is at some height. But if the crop is at this height, we can do nothing. We cannot spray. Before 2 years, there was no need of spraying pesticides over maize crop. But since last 2 years, we were badly affecting by fall armyworm, and we used to spray 3 to 4 sprays of pesticides or maize also. Even in this height also, when the crop reaches this height also, we are trying to spray something to control fall armyworm. So my appeal to the rulers and governments on behalf of farming community, please allow all the new emerging technologies in agriculture sectors, just like in other sectors like medical field, communication field, and industries. Since there is no chance of expansion of fertile land to grow crops to meet the food requirements of the fast growing population, the way is to adopt new technology to get higher yields in the same agricultural land, in a limited land. So then only we farmers, our farming community, will compete with the other farmers of the other nations. Thank you.
নমস্কার, আমি পশ্চিমবঙ্গের নদিয়া জেলা হরিণঘাটা ব্লকের নাপিসাতবেড়া গ্রামের একজন কৃষক। আমার নাম উমেশচন্দ্র দেবনাথ। এই বেগুন চাষের সঙ্গে আমি প্রায় 35 থেকে 40 বছর যুক্ত। আমরা যেই জাতগুলো চাষ করি সেগুলো হচ্ছে মূলত হাইব্রিড এবং যেগুলো গ্রাহকদের খুবই পছন্দ। প্রথম দিকে আমার খুব লাভ হয়েছিল, কিন্তু ইদানিংকালে এই বেগুনের ডগা ছিদ্রকারী এবং ফল ছিদ্রকারী যে পোকার আক্রমণ উপদ্রব, যার ফলে আমরা প্রতি বছর এই বিভিন্নভাবে পোকার ওষুধ ব্যবহার করেও আগের মতো আমরা লাভ পাচ্ছি না। দিন দিন আমাদের ফসলের ক্ষতি যেমন হচ্ছে, আমাদের প্রাকৃতিকও ক্ষতি হচ্ছে। এই অবস্থার থেকে আমাদেরকে মুক্তি পেতে হবে। আমরা যেই ফসলগুলো নতুন নতুন ঔষধ কীটনাশক ব্যবহারের ফলে এই যে পোকাগুলো আছে, পোকারও শক্তি বৃদ্ধি হয়েছে, যার ফলে আগের মতো আমরা ফলন যেমন আমরা পাই না, তেমনি আমরা ভালো ফলও তুলতে পারি না। যার জন্য ইদানিংকালে যে সমস্ত খারাপ ফলগুলো আমাদের হয় সেগুলো কৃষি মান্ডিতে বিক্রয় করতে গেলে আমরা খুব কম দামে বিক্রি করতে হচ্ছে, যার জন্য আমরা প্রচুর লোকসানের সম্মুখীন হচ্ছি। এর হাত থেকে আমাদেরকে মুক্তি পেতেই হবে। আজকে এই কীটনাশক ব্যবহারের ফলে আমাদের মাটির ক্ষতি হচ্ছে, আমাদের প্রাকৃতির ক্ষতি হচ্ছে, এমনকি আমাদের দেশের এই ফসলের বন্ধু পোকা পর্যন্ত ক্ষতি হচ্ছে। আমাদের দেশের মানুষের যেমন ক্ষতি হচ্ছে, তেমনি গবাদি পশুরও ক্ষতি হচ্ছে। এর থেকে আমাদের মুক্তি পেতেই হবে এবং এর জন্য আমাদের যে কোনো ভাবে আমাদের এগিয়ে যেতে হবে। আমরা শুনতে পাচ্ছি যে আমাদের দেশের বিজ্ঞানীরা এই নিয়ে গবেষণা করছেন এবং তারা চেষ্টা করছেন এই ডগা ছিদ্রকারী এবং ফল ছিদ্রকারী পোকার বিরুদ্ধে তারা একটা প্রযুক্তিগত বীজ আমাদের সামনে নিয়ে আসবেন, যেই বীজের ফলে আমাদের আবার পুনরায় আমরা আবার ফলন পাব। আমরা আমাদের পাশের রাষ্ট্র বাংলাদেশ, সেখানে তারা কিছু কিছু বেগুন বীজ ব্যবহার করে। এমনকি আমি যখন বাংলাদেশে গিয়েছিলাম, আমি সেখানে কৃষকের সঙ্গে কথা বলেছি এবং দেখেছি তাদের বেগুনের মধ্যে এই ডগা ছিদ্রকারী এবং ফল ছিদ্রকারী পোকা নেই। তাদের খরচ কম, তারা বেশিরভাগ লাভ হচ্ছে। তাই সরকারের কাছে এবং বিজ্ঞানীদের কাছে আমার অনুরোধ যে অবিলম্বে এরকম একটি প্রযুক্তি এনে আমাদের কৃষক সমাজ এবং বিশেষ করে বেগুন চাষিদের উপকারের জন্য আপনারা এগিয়ে আসবেন। আমরা যদি এই কাজটা করতে পারি, শুধু কৃষকের উপকার হবে না, ক্রেতাদেরও উপকার হবে। যারা এই সব সময় আমাদের ক্রেতাদের প্রয়োজন, তারা আজকে ভয় পাচ্ছেন যে আজকে এই ফল আমরা খাবো কিনা। সেই জন্য আমরা আপনাদের মাধ্যমে আমরা সরকারের কাছে আবেদন করছি অবিলম্বে এটা করা উচিত। আমি একজন কৃষক, কৃষি হচ্ছে আমার প্রধান জীবিকা, এবং আমি যদি এই কৃষি চাষ যদি আমাদের না থাকে তাহলে আমাদের জীবিকা রক্ষা করাও কঠিন হবে। আগামী দিনে আমাদের সমাজকে রক্ষা করার জন্য, আমাদের মাটিকে রক্ষা করার জন্য, আমাদের চাষকে রক্ষা করার জন্য আমাদের এগিয়ে যেতেই হবে এবং আপনাদের মাধ্যমে আমরা সেই আবেদন করছি। আমরা সর্বশেষ যে কথা বলবো যে আপনারা আমাদের বাস্তব অভিজ্ঞতা এবং আমাদের এই যে সমস্যাগুলোর কথা ধৈর্য ধরে শুনেছেন, তার জন্য আপনাদেরকে আমি আমার অন্তরের অভিনন্দন ধন্যবাদ জানাচ্ছি এবং আমার দৃঢ় বিশ্বাস আপনাদের চেষ্টায় আমরা এই দুর্বিষহ যন্ত্রণার থেকে আমরা মুক্তি পাবো এবং আগামী দিনে নতুন একটা আমরা সূর্যের আলো আমরা দেখতে পাবো, এই আশা রেখে, আবেদন রেখে আমার কথা আমি শেষ করছি।
Thank you so much. So listeners, I think you've had a feast of viewing agriculture fields from 8 different states. You had a feast of points coming straight from the farmers themselves, their experiences and their frustrations, and hopefully their requests which can be taken forward by us, by the governments, and by other stakeholders. We had a variety of farmers, marginal farmers, we had mid-sized farmers, and we probably had some larger sized farmers as well. So again, like I said, the Pro Agri Science Forum, which we've established thanks to Mr. Ravi Ravichandran and many of his friends, is a huge forum where we have 250, 300 members directly speaking to each other on a day-to-day basis with other farmers and also with scientists and also some policymakers. So this is happening. So now I want to just summarize a few points as take-home messages, from the farmers that we have, and then immediately after that we will have a Q&A session. Okay, if I can go to the presentation that I had for summarizing the farmers' viewpoints, then I can quickly go through that, and then after that we will have a Q&A session where our scientists and hopefully Mr. V. Ravichandran, I don't know if he's able to connect to the speakers lounge, but he can. If he can, any questions that may be directed to the farmers. So can I have the presentation that I had for just going through a few points on the farmers' viewpoints, please? Thank you. Next slide, please. So this is, like I said, this is only a list of few farmers and scientists we could accommodate today. All are Indian and no visitors, no people from other countries. And they work with us regularly, and there are many, many more, like I said. We had farmers presentation from 8 states of India today. Hopefully in the next webinar, we will have farmers from other states as well. We have many more real-time interactions with other farmers, and hopefully we'll be able to bring them to you, even farmers from the other countries. A few take-home messages in my next slide that I've tried to put together. We know that what farmers are saying is that we know what will work for us and what will not work for us. So please give us a chance. And they're saying we need technologies of the best kind in agriculture, so we have it as we have in other sectors. You heard today, we farmers are equally and maybe even more concerned with soil health, environmental sustainability, and so on. You heard today by many that we need technologies like BT for other crops also to be globally competitive. My next slide, please. If you have other technologies which work better, please come and grow in our fields side by side, as a farmer, Mr. Kang from Rajasthan, put it in the very first video. So he's welcoming people who may be skeptics, who may be opposing this technology, to go visit him. He will give a plot to you. You can grow a crop of interest, say cotton, using technology that you think is better. Please do that side by side and then see what happens. Then farmers are also saying, we want to follow legal route at all times, but why are we facing so many hurdles? Why do we want to follow the legal route? And as you heard from many farmers, there are farmers who are graduates, who are postgraduates. It's heartening to see many of the urban educated students are going back to their villages, their towns, or to their taluks to carry out farming. This is a really good sign. We want more of young people to really go back to their respective villages and help growing crops for us. And many other farmers may not have degrees, may I say, but they're very competitive about their beliefs and knowledge, so they know what they're doing. No technology, what they're saying is that no technology can cheat farmers for more than one season. We must remember that. So what they're saying is, please make it easier to decide it for ourselves. So before I go on to Q&A, I really want to thank the scientist speakers, the 8 farmers who were part of this webinar, farmers from 2 other countries. Unfortunately, we could not host them today, hopefully next time. Mr. Bala Sahib, Mr. Arup Paul, Dr. T.M. Manjunath, and Mr. Ravichandran for helping translation of the languages spoken by farmers from different states, and all the participants for coming in here. So now I would like to move on to the Q&A session. Please kindly put your questions, and then we will see how many can be answered. Thank you. While the Biotechnica platform is trying to get a few questions going, I can start off with one or two questions. Is that okay, Shekhar?
Yes, sir. So we will try to quickly have the questions on the screen. In the meanwhile, a few questions which you want to take up, you can.
Okay. These are some of the questions that were sent to me by a few people once they came to know about the seminar or the webinar happening, and then for them who could not be there to directly pose the questions on the chat box. The first question is, in one of the recent webinars held, I think a couple of weeks ago, there was a question by a leading Indian cotton scientist. In that webinar, why are farmers so obsessed with BT cotton? So if Dr. Mai can answer that, why are scientists so obsessed with BT cotton? Dr. Mai. Is Dr. Mai there?
No, he is not available right now.
Okay, can I pass it on to Dr. Manjunath?
Dr. Manjunath, can you hear us? I think he's on a mute. Dr. Manjunath,
right.
Can you hear us?
Dr. Anand Kumar, would you like to take that question?
Oh, yeah. Basically, we can cite two reasons for this. One is after the introduction of Bolgard 1 and Bolgard 2, and also very good management practices like good fertilization, irrigation, etc. The incidence of sucking pests has increased. And we know that BT technology doesn't manage or control sucking pests. And the sucking pests, in fact, have been taking quite a bit of pesticide sprays. And the other reason is pink bollworm. The pink bollworm resistance to Bolgard 1 and Bolgard 2, especially in the past 4 to 5 years, in certain regions, starting from Gujarat, Rajasthan, Maharashtra, Telangana, Karnataka, has devastated BT cotton, if not wholesale, but sporadically and in certain pockets. And as we have already mentioned about it, basically it can be traced to the problem of non-compliance with refugia. So we have to go back to the farmers. Number one, compliance with refugia. Number two, use short duration varieties so that pink bollworm infestation can be avoided late in the season. And number three, use insect integrated pest management technologies wherever suitable. And the most important thing is very simple agronomic practices like sanitation, crop rotation, and other economic measures like that. So we do understand there have been some problems with BT cotton. Farmers are getting dissatisfied with that. But these problems are not insurmountable. That's what I mentioned. There has to be a concerted effort, collaborative effort, starting from the seed companies which have been marketing different genotypes and going up to the farmers level and with active participation of NGOs. Thank you.
All right. Thank you so much. There is a question. Maybe I see Mr. Sudhanshu Kumar, who is there representing farmers because Mr. Ravichandran could not come in. Thank you, Sudhanshu, for coming into this webinar. So yeah, there is a question. there's a question that both scientists or you could start answering that. In spite of volumes of data across the globe, benefit studies, academic statements, public perception is still ambiguous. Where are we going wrong? Is it time for scientists and farmers seriously think of communication strategies which are not just fact-based, but actually, incidence-based? Do you have any views on that?
Yeah, like let's say if I can give you an example from Bihar. I mean, no one knows about GM. I mean, no one talks about it out here. Okay, maybe in West India, in Gujarat, Andhra, Maharashtra, Punjab, because there's BT cotton, a lot of farmers are talking about BT and GM. But let's say like in a state like us in Bihar, I mean, the farmers out here have nothing to do with GM. They don't even know how GM can touch their productivity, their input costs. I mean, when I read about it, when I listen to you all, when I've gone abroad to see other farmers, corn growers in America and all that, and when I talk to them, they say ki if today GM would have to be taken away from us, we wouldn't be able to do farming. And I, as a farmer, I grow corn, I grow wheat, I grow mustard, and I have a lot of, I'm converting from cereal crops to fruit crops. And I can see, I grow lentils also, and I see what the effect of the pot boring worm and mustard made the same problems that come in. But in Bihar, no one, if you go to any forum in Bihar, no one is talking.
Sudhanshu, basically, I think what we want to know is, of course, we've seen all that from all the 8 different farmers that we've had today. But to get this technology to more farmers, what do you think should be the communication strategy? I mean, today we probably crossed a borderline saying that by bringing in farmers from different states speaking in different languages. What else do you think, very briefly please, what else do you think should we be doing to help communication, saying that this technology is here to stay, is safe, and all of that? Just in a few sentences, please.
What we need to do is bring it in front of the farmers in a more communicative way, where I suppose everyone can't attend a webinar like this, but at local level, in the local language, farmers should be made aware of the benefits of GM technology. Right now, it's more negative. It is a positive which has to be brought down to the grassroots level in the local language.
And hopefully this webinar being hosted by Biotechnica and Pro Agri-Science Forum will be able to help that. Thank you so much.
Yeah, it's a nice step in that direction.
Dr. Anukam, do you want to add just 1 or 2 sentences to that? In terms of what else do you think we should be doing to communicate this better to the other farmers and other stakeholders? Dr. Kumar, did you get that question?
Oh yeah. In fact, this matter of public perception has been there for more than 2 decades. And again, I would say, unfortunately, there hasn't been good communication between scientists and the farmers.
So what do you think we should be doing going forward?
Pardon?
So what do you think? Yeah, we know that, but what do you think we should do in step 1, step 2 to get to be more
popularization of biotechnology, specifically GM crops, in local languages by Indian Council of Agricultural Research, agricultural universities, and the local ICR institutes in each and every state, in each and every language. They should publish papers, newspaper articles, write brochures in, let us say, Punjabi, Tamil, Kannada, Marathi, etc. In fact, when I was director of NRC and Biotechnology, we have ran an Ag Biotech newsletter for 5 to 6 years in 12 different languages and distributed by ICR to all KVKs. But somehow, unfortunately, it has stopped. Thank you.
Thank you. Thank you. Shekhar, do you have any questions from the chat box?
Yeah, we have a lot of questions coming in, and we are already short of time. So I'll just quickly select 3 questions from the random questions. Okay, so everybody, I know you have a lot of questions, but it's going to be very difficult actually to take up all of them. But yes, you can always comment later and we can answer them individually. Our farmer friends as well as scientists will always be there. So starting with the first question, it has been always been like, is GM crop safe to eat? That's the question which keeps coming up. I can see a lot of questions related to that. So probably somebody can take up that.
Dr. Kumar, Anand Kumar, briefly, please.
Yeah, I can take any specific questions.
No, the question was, is GM crop safe to eat?
Are GM crops
safe to eat? Safe to eat.
Yield.
Eat. Kana. Edible.
Oh, okay. Edible GM crops. Okay.
Are they safe?
It is very well known that GM crops have been under cultivation since 1996, now in 24 countries. And most of the GE crops have been food crops. It's only few crops like cotton are fiber crops. But of course, if you consider cotton seed oil as edible, it is also a kind of edible crop. So basically, whether it is a vegetable or a pulse, an oil seed or a fiber crop, all the GE crops globally cultivated in the past 24 years, 20 years in 24 countries are edible crops.
Okay. All right. Thank you.
Can I just chip in? I have a very nice example to give.
Yeah.
Can I?
Okay.
Go ahead.
Okay.
See, this pro-agri science group that we have, and Ravichandran ji and Chengal Reddy ji and all, we once went to Khan Market, and at random we picked out products from the shelves. And you'll be surprised, out of the 20 products we pulled out just at random, edible stuff, 15 had GMO written on it. It is so surprising. I mean, you can buy GMO from the market, but farmers will not get the GM technology. I mean, this is how edible it is. It's there everywhere. You just have to open and see with your eyes what's written on the label.
Okay. So we have our next question. All right. Thank you. So now we have our next question from Siddhanta, and he asks, can farmers save their BT cotton seeds for replanting?
Shall I?
Yeah, go ahead.
Yes, now we have 8 varieties of BT cotton released from CICR, that is Central Institute of Cotton Research, and Punjab Agriculture University and PDKV in Maharashtra. These 8 BT cotton varieties give a scope to the farmers to save the seeds and replant them. But the BT cotton hybrids, or the seed of BT cotton hybrids a farmer buys from a company, cannot be replanted, because in the F1 generation, the plants get segregated and the farmer loses the benefit of insect protection. So the farmer should go for varieties released by public research systems if he wants to replant the seeds.
Okay, I hope that answers your question. All right. In the meanwhile, audience, if you want to fill the feedback form, the link is given in the chat box. You can always click and do that. And then please come back so that we can continue our Q&A, which will take another 2 to 3 minutes. Okay, we have an important question coming up, and that is from Sheena. And she asks, is the BT strategy alone will be effective in controlling the intense pest attack common in tropical countries like India? Can that really be addressed by BT? Over to you.
Dr. Kumar.
Yeah.
Anand Kumar.
BT strategy alone is not really a wonder bullet. We have many other strategies and approaches now. The upcoming genome editing technology, the RNAi interference technology, all can be combined with BT. Not only that, in fact, the BT cotton or BT crop cultivation should be an integral part of integrated pest management if you want to have sustained benefit of BT. Integrated pest management practices, as you all know, it includes biopesticides, biological control agents, insecticide and viruses, etc. And these are all quite old technologies. So the old technologies as well as the new upcoming technologies like genome editing can go hand in hand so that we can have a long, sustainable pest managed crop cultivation.
All right. I hope that answers your question. Okay, we are taking this last question for the day by Gurpreet Kaur. Does GM crop affect the other traits or molecular changes in the plant, like any triggers to the physiology, which becomes inevitable later? Over to you.
In fact, in some events created by genetic engineering technology, there could be some inadvertent, unforeseen effects on physiology, biochemistry, and other traits in the plant system. To rule out this kind of inadvertent effects, we subject a particular event to intense GM regulation. I have seen, in fact, I have shown in my slide the kind of biosafety and environmental tests that are employed to make sure that except for the trait we want in the GE crop, no other character, physiological or biochemical or any other, is affected in an adverse way.
Okay.
Okay. All right. So with this, we have almost finished. Over to you, Dr. Jagdish. Some closing words.
I just want to thank all the participants, speakers, starting from Dr. Padmanabhan, Dr. Mai, Dr. Manjunath, Dr. Anand Kumar, on the scientist side, and the incredible number of farmers who have logged in, and the 8 farmers who actually spoke for us, and many others who contributed in the background. And my final thanks is to Mr. Shekhar Suman and Team Biotechnica, for them to have hosted this particular webinar. Thank you so much.
Thank you, Dr. Jagdish. Not sure your camera turned. Now it is fine. Yeah. All right. So
thank you so much,
thank you. With this, we come to an end of our session. It took 25 minutes extra than expected. We apologize for that, but I am sure you must have had a wonderful experience, a unique experience where we didn't just bring the scientist. We brought in the end user, which are our beloved farmers. Our country, since its birth, has been saying Jai Jawan, Jai Kisan, but have we really paid off our debt to our farmers? That's the question to be asked today. Before we sign off today in this webinar, I have a few words of gratitude to share and say to all my beloved audience, our expert speakers, our scientists, and of course, the farmers of this country. If we really want our nation to progress, then we must stop being self-centered. We must be nation-centered. And if we have to become nation-centered, then we should not waste time in controversies. We must take out funds as well as time and invest them into right technologies and give those tools in the hands of eligible farmers who can take this up forward. My dear subscribers, fans, critics, and experts at Biotechnica, it was a real pleasure hosting you all today in this webinar. As I sign off, I only wish to say, don't forget your farmers. They are the ones who bring food to your table. So next time when you go into your lab, in an agri lab, and are doing research on agri sciences, remember them that you are the enablers of tomorrow's food creators. So with those thoughts, thank you so much. And do not forget to fill out the feedback form. After that, after a few hours from now, I'll be sending an email with the ebooks, which we are going to give to only those who attended till this point. And of course, the e-certificates will also be issued to you in the next 3 working days. All right. and see you soon. And yes, one more thing, do not forget to share your e-certificates on your LinkedIn profile. That will help you enrich your profile. See you soon in our next webinar. Okay. Thank you so much and have a wonderful weekend. Bye-bye.